Oh, hello. Good morning. This is Boix. All right. Here we are. So, I was testing the thing. Um, how fast is it to compile my programming language cast, my Rust code? And it's very slow. So I'm going to try to fix that. Okay. So right now, if I try to build the thing from scratch, I tried that already, right? So if I do Firefox target, cargo timings, cargo timing, HTML, this is the thing. This is how fast it is to compile cast from scratch. It takes 53 seconds, 54 seconds total. But I switched to nightly too, just in case. But yeah, basically the entire thing is spent in my final crate, and it takes 45.5 seconds. This is the graph. So this is me compiling dependencies. I'm using 100% of the CPU here, and then later I'm not using any CPU, and it just like slowly compiles. And I need to figure out why is it that slow, because I don't think I ever seen anything compile this slow. There is also this, what does this mean exactly? There is blue and purple here. What does this mean? This means code gen, right? Whatever code gen means. So code gen takes 8% of the thing. Code gen is to actually generate the binary, right? So I take 45 seconds, 3 of which is just generating the binary. Can I have more detailed information though about this? I don't know. Like, for example, is it possible in Rust to see, can I see how much time is spent in proc macros when I'm compiling my Rust? You can. Z time passes in each compilation phase, including proc macros. There's parsing, expand crate, checking procedural macros, and this thing, right? For even more compiler introspection, you can do cargo nightly build Z timings. No. This is exactly what I'm doing, though. I am doing timings. I am literally doing this. Let's do this from scratch. Cargo clean. Cargo. So they say Z time passes. Time passes used with cargo build to provide detailed insights is how much time spent different stages of the completion process. How to identify compilation time profiling tool. Well, you can use the experimental flex self profile that will give you an idea of what the compiler is doing. Type checking, borrow checking, code gen, linking other. There's time passes and there's self profile. Where is this documented? Rust flags. So build Rust flags. In contrast with Cargo Rust C, this is useful for processing to all compiler instances. Mm. Mm-hmm. Mm-hmm. Where's the documentation of all of the things? Where docs or time passes? You don't give me the link to the doc here. Google doesn't give me the link to the doc. Z time passes. A list of possible Rust flags. Configuration. Rust flags. How do I know? Rust C help. Rust C Z help. Z flags. Here's my Z flags. All right. Time passes. Measure time of each Rust C pass. What else about time, right? I want time. There's time LLVM passes. Time passes. Time. Self-profile. Run the self-profiler and output the raw event data. There's also this. Okay, let's do this. Rust flags is Z time passes. Z human readable type passes. Is that a thing? That's not a thing. Z time passes. Z self profile. Z timings. Cargo build. Unknown unstable option timings. Yeah, because timings is now a known stable option, or you just do timings here. There is some prof data. So there we go. This is all of the dependencies compiled, and now I'm waiting for the final thing, for the final crate, for cast itself. Coherence checking. Yeah, maybe I can see some things here. As derived macros. Either binary or unsupported. Z flags. Prof data. Can I open this prof data somehow? Okay, finished in 1 minute 8 seconds. Timing saved over here. I can open the timing, right? Here is the timing. Yeah, this is right now. Okay, so once again, as this time took 51 seconds, more than before. Okay. And then there are dependencies. Okay. All right. Okay. So what is this? Let's see. So it says compiling cast, and it says, okay, I see it. Total 1.4 second. That's incorrect, but I did see a big number here, and it is. Oh wait. Oh, there are two totals. That's right. This is the library. This is the binary, because I have the library and the binary crate, right? Parts of the crate. Yeah. Look at this. Monomorphization collector graph walk. Farmer, hello. Type check crate, 22 seconds. Monomorphization collector graph walk, 20 seconds. Generate crate metadata, 22 seconds. So it's not even the procedural macros, which I was like thinking about. It's just type checking that is slow, right? Interesting. Interesting. All right, so I figured out where my time is. This just means that I don't need to spend time trying to get rid of the procedural macros, because it doesn't matter. Okay. All right. So what we do about this, usually when you ask how to improve the compilation times in Rust, they say you need to split your crate into multiple crates. So I guess I will try that. Too much generics or something. Yeah, because monomorphization collector means a lot of generics, right? That's what it means? I'm gonna do this from scratch, but save this to a file, because why did I not do that first? Cargo clean. This save to roll file. I don't know, timings. TXT. Like this. By the way, maybe I just need the time passes. Maybe I don't need the profile. Hold on. Like, what are all of these files? Like, I might not need these files, right? Move to trash. So yeah, that's what self-profiling is doing probably. I just need the time passes. Let's also save this to adjust file. This will be called check compile times. We will do this, and before that I will do cargo clean. Timings txt. Okay, here we are. Compiling a bunch of stuff. This is the important part in the end. Cast. Wait, can I also... Wait, I don't know. Does this write the things? Like, it's trying to compile the crates in parallel, right? In order to read this code better, I probably want to have the jobs. Can I build dependencies only? .5 GB binary, please God, what the hell is happening? Not in cast, in Inksider, yeah. I mean, I can look at this as well, but I don't know. Projects Linksider. So here's my target, right? Here's my target. Debug. I'm talking about debug builds, not the release builds. I'm using dynamic linking for that reason. So here's my basically. This is all of the dependencies combined, linked into a single binary. Your batcop file is smaller. Yeah, but this is all of my. This is just dependencies combined, put into a dynamic library. It's not my code, all right? You might ask, what is my dependencies? Well, dependencies. Here you go. You're right. I have this actual dependencies crate, you know, kind of thing, which is this. So this is all the crates that I put into this dynamic library. It's my game engine, like a couple of other things. What's exactly there so that it's half a gigabyte? I don't know. Okay, is there a way to figure it out? They can just strip stuff because it's dynamic. It's not like, no, I put it into the dynamic library because I had the big binary, I think. I was like trying to improve my compilation times there, right? We can try this. Cargo build. No default features like this. This will compile it statically, not dynamically, right? Let's see how big this file is going to be then. Because like this is just going to put the entire thing into the binary instead of dynamically linking to it, right? So my actual Linksider binary is going to be half a gigabyte. How large are the release builds? Release builds are relatively small. We can see, like, maybe in these pipelines, probably. Like over here, like which we can see, like Windows, for example, right? I'll build this Windows 500. Nice. Nice job, GitLab. Really? Also 500? You use GitLab too? It's just for the browsing these things. The other parts. What about downloading? I guess I can download it. I don't know if I have the binary. We'll see. Yeah, so see, now Linksider, it's actually like 583 megabytes. This is the binary, all right? We can take a look at release. Release is 42 megabytes of dynamic linking plus 8 megabytes, so 50 megabytes instead of 500 megabytes. Still literally 10 times smaller. Oh, you're making a joke, 500 megabytes? Yeah. I don't know, like there's some debug data. I guess it's not optimized or something. Like a lot of dead code, maybe. I don't know. Anyway, if you haven't seen this, if you just joined the Raymarch, I found a flag for the Rust C, which is called time passes unstable flag. So this shows me all the time passes in the Rust compiler, right? How long does it take to parse the crate and stuff? So here's in the very end when I'm compiling cast itself. It says 20 seconds for monomorphization collector graph walk. So monomorphization takes 20 seconds. Type checking takes 22 seconds. Generate create metadata takes 22 seconds. And this results in a total of 50 seconds. This over here, I believe, is my like library crate. This below is my binary crate. Then that depends on the library, which only takes 1 second after that. So yeah, just parsing the crate is 1 millisecond. Macro expand crate. This is so this over here is running the procedural macros, right? Macro expand, I'm assuming, includes the procedural macros. Oh wait, this is something else maybe. Like I need to make sure that it's not like like this over here has the timings like because it's running it in parallel. I probably need to say that this should be jobs 1. Let's just do jobs 1 here. Just check compile times. This way, it's going to be easier to understand this output, I guess. But is there a flag to compile the dependencies only in Rust? I would like to do that, because I don't really care about my dependencies much. They are fast. Can I just compile the dependencies of my cargo workspace? Why is it yelling at me? You no need to rebuild your masterpiece every time. To build dependencies that not your create, use cargo check z build std. What? Cargo clean your root crate. Can I clean all of the crates from the workspace? Wait, can I do cargo clean workspace, for example? Is there like a cargo clean workspace thing? No, it only can select the packages. It would be nice if it was like if it could do that. All right. Anyway. Okay. Here's my timings now. Here's the end. Right? I was compiling. Yeah, so here's the binary. It takes 2 seconds. Here's the library, takes 58 seconds. Yeah, so this time I'm just not doing any work in parallel at all, which is why it's a little bit slower. But anyway, I see LLVM passes 10 seconds and code gen crate 11 seconds. Generate crate metadata 22 seconds, monomorphization 20 seconds, type check 22 seconds. And that's it, right? So there is also parse crate, AST validation, macro expand crate. So this is the procedural macro, I'm assuming. They don't take any time. Okay. This is one of the reasons why I moved away from Rust. Life in C is so much more simpler. My game right now is 800 kilobytes or something. Well, I mean, I guess it's a trade. I mean, you can write code in the same way as you write it in C. I think, like, if you want to do that, I would rather just stay in Rust, just write my code in a different way. Like, you can write code without using generics, without like doing a bunch of stuff, and it would be much better than C. I don't know. I would not go to C just because I have slow compile times or big binaries. It doesn't matter that much. Like, the amount of time that I will spend hating C is going to be much bigger than my compile times. Alright, anyway, so what I'm going to try first is just to try and split my code into multiple crates, basically. Let's do this. I have already some crates, but not a lot of splitting is happening. Mostly it's just like the parser, the AST parsing is separate right now. Which, by the way, takes almost no times at all. Cast AST is like the fastest thing ever to compile. Right? Cast util less than... Yeah, cast util is like almost a second, actually. Cast derive macros, I think, is like the big one. So just compiling the derive macro is slow, which is weird. It's slower than actually using it. Cast inference, half a second. AST is almost a second, yeah. In my C++ engine, I ended up doing some intense workarounds to enable forward declarations for templates. Wait, can you forward declare templates? I guess you can. Speaking about forward declaration, you know what? Sometimes I think this is what I'm missing from Rust. This is sometimes I think that's what I'm missing from Rust. I wish sometimes that we had header files, because I want to basically take a quick look at my like public API, I guess, which I can only do by basically generating the docs right now, which is annoying. Like OCaml has the signature files, for example. C++ has header files. I want something like that sometimes. A VS Code outline view. No symbols found. Oh, it's the TXT, of course. Is there outline for the crate? I mean, my Rust analyzer is disabled right now because I was checking the compile times. All right, anyway. Just check compile times. All right, let's try first by splitting the library and binary, because my crate right now is actually two crates, right? We have a lib and we have a main. Okay, so let's remove the source and let's have just the crates. So I want to do cargo new lib. What do I do it? So I can have the library called cast and the binary called cast bin, for example. That's how most people do it, I think. Or I can do cast lib. I think just cast, because like if you add a cast as a dependency, it would better be called cast, right? But for the binary, it doesn't matter much. We do cast, and we do cast bin, I think, like that. This is cast. And this is cast bin. Maybe the compiler has a fast path for people that don't implement a trait in an expression in an arc constructor, just saying. A trait in an expression in an arc constructor. Your ideal language is slowly approaching C++. I mean, my problem with C++. Like a lot of people, for example, complain about C++ because it's bloated language. That's like absolutely not my issue with C++. Like, I want my language to be bloated, so yes, it is going to be kind of similar to C++, I guess. In that sense, because I want every feature. I want multiple ways to write the same code. People think that it's a bad idea. I think it's a good idea to have multiple ways to do things. Impl output form, I just saw that. Plus you pay maximum complexity and still get nothing in return except performance. Well, yeah, but performance is the reason to use C++, basically, right? Is anyone who is not caring for performance using C++? Okay, so this one is going to be just the workspace and the workspace package and workspace dependencies here. And then this package. What about profile? Is this belonging to a package? Profile release, debug true. Like, does this need to be in every package? Have I tried Zig then? I have tried Zig, yes. Zig has not a lot of features. Zig is a language which has the things that... So the features that they have in the language are good, but there are like a billion features that are not in the language. Because they have this like idea of a simple language, it makes it a bad language in my opinion. Because like I want the features, you know? the language is not expressive enough. It means that I need to write a lot of the code myself, like the inference. I don't like the way inference works in Zig. The lack of like traits and stuff. They have the they don't have like safety, right? Well, I mean, Rust is the only language that has like safety, basically, out of the low-level languages. I guess like if I was to choose between C++ and Zig, maybe I would choose Zig. Probably. Wait, this is my library crate. Source. Compiler, interpreter, JavaScript, scopes, cast, comments, context, executor, ID, this, lib, name, place, Rusty target type value. All of these things go into this place. And then these three go into the binary crate. Hello, Modprog. I get why they don't have traits. It adds overhead under the hood. Whereas implementing vtables yourself, you see the overhead in code. Traits themselves, they don't add the overhead. The dynamic dispatched traits, which require the vtables, have overhead. I have a feeling that there is a way. So like, because like in Rust, you can use the traits with static dispatch, right? And then they don't have the overhead. I have a feeling there is a way to have in a language. I haven't like thought much about it, but I feel like we can like basically in Rust, the implementation, like how exactly is the dynamic trait represented, is specified by the Rust compiler itself, right? We cannot customize it, where in Zig we can, which is kind of nice, right? I have a feeling that we can have a language which allows you to customize it while still being as even in Zig, I think even in Zig, can you not like make with like some compile time magic, you basically have the definition of the trait in the form of a struct, I guess, and then you generate based on that the code that converts it into like a trait object. Yes, yeah, I'm pretty sure you can do that. So like, yeah. The problem though is that there is a lot of verbosity still. Like even although you can generate that stuff yourself, using Zig is still very verbose. Like they have this like idea that everything must be very explicit. I'm not sure I like that. Like just using generic code, you need to instantiate your like templates basically explicitly. You don't have the type inference like in Rust. There is only like some simple type inference. You need to like specify, like you need to pass the types basically to your like generic functions always, which is very annoying in my opinion. It makes me not want to write much generic code. Source. Okay, source is now empty, so I don't have this thing at all. Cargo check. Failed to load dependency for cast inference. Failed to read cast line crates, cast crates. Why? Because in this dependencies probably I have some path ones. Yes. We need to do Wait, can I do like inference, package cast inference, but then say workspace is true here? So that I can rename the thing. To be honest, I thought verbosity was too much in the beginning, but I grew used to it. I mean, you can grow used to everything. Sure. Like, I can get used to the slow Rust compile times. But, like, I guess, like, in Zig, you... you see the verbosity in the very beginning and then you get used to it, while in Rust, when you just start your small project, it starts small and it compiles instantly, and then eventually we are here with 1 minute compile times, and at that point it's too late. Like, I have to get used to it. Any of those languages let you avoid modeling invalid states though? Zig, Odin, and Go. No, yeah, that's, yeah. Yeah. Zig in particular, like, I still remember reading about their argumentation for not having the private fields. And it's just so stupid. Can I say, whatever, let's just do that. Dependency inference was not found for workspace dependencies. Yeah. Workspace dependencies. So I just, wait, can I? It would be nice if, like, all of the crates from the workspace were automatically, like, passed, were automatically, like, specified here in the workspace dependencies, you know? But basically, cast inference, path, crates, inference, like this is what I need. This doesn't work. This doesn't work. I need to actually call it. So I cannot rename a dependency which is in the workspace. Okay, I think I will just call it cast inference then. This is annoying a little bit. Should they have problem but much better than C itself? Yeah, sure, C is horrible. It's not that difficult to be better than C. Have way better static analysis than C, not than Rust, right? You like Rust a lot, but it is a buy-in to all of the complexities that comes with the safety it provides. Sure. But I'm okay with complexities. Like, the reason I don't like simple languages and languages that market themselves as simple, like Zig and Go and like C, whatever, is because, like, the programs that I write, they are complex. So the complexity needs to be somewhere. I prefer it to be there in the language instead of being in my code. Because, sure, like, you need to learn Rust to write Rust, but I think it makes the code simpler. So I think Rust is a simpler language because of that. It's not a simpler language to learn, but it's a simpler language to use once you, like, actually learn it, basically. My thoughts are that that's better. You cannot build a project beyond a certain size without those guarantees. I remember, like, so I was writing before Rust, I was writing C# a lot, and then I was trying out, like, different languages. One of the languages was, like, D language, and I liked D language a lot, but because I'm a bad programmer, I guess, I was doing the null pointer exceptions a lot, and in D language, the null pointer exception doesn't exist, they just give the user the segfault for some reason, and I just rage quitted and went back to C#. I don't know. Like, I want someone to help me write the code. I'm actually surprised why D language doesn't have, like, the runtime check for nulls, at least in debug builds. Do they still not have it? Does dlang has option to enable null checks. Like, because if you like Zig, I think that D language is just a better choice than Zig, in my opinion. D language also is a language that compiles fast. It also has compile time evaluation, like Zig. It did it just 20 like years earlier than Zig. It has more features. D doesn't have a compiler flags like null check. It offers save. So like the problem is like you use save D and then you still have the seg faults. I remember using that. Other than that, the language is better. You meant more in terms of implementing common data structures, especially those that are cyclical or self-referential. So either you do the easy things and add overhead with ref counts, or go the unsafe route anyways. Yeah, I guess. But like, how often do you do that? I mean, I do basically the inner mutability. But I don't know. We talk about languages as if it still mattered once cast is out. Not going to be out soon. Not if I not fix my compile times here. All right, I need to have the binary dependencies specified. All right, cast bin. This dependencies is going to be like cast itself. I just want to specify all my dependencies in here. Cast workspace is true. I want colored workspace is true. I want tracing subscriber. I want IRI. And I want clap. Anything else? Tracing itself. And then cast. I want to call this then just cast derive macros, not derive macros. Cast path rates cast. And let's see, we have AST derive macros inference. You know what I also would like? If I split my crates like this, can I have this tree view sorted topologically so that like, you know, the dependency is always before the final thing? Like, I want the cast bin to be the bottom. Meanwhile, I'm fighting this Steam review process. Wait, you have a game? I thought you were just making the shame. You were working on a game secretly? Renamed to ZZZ cast bin? Yeah. Having numbers here, like manually doing the order, is one option. Help Axo with a game. Releases soon. I thought Axo's game, I saw that on Steam already. I'm pretty sure that there exists the Steam page, right? Util. Derive macros not found. Source derive macros. Cast derive macros. Derive macros. Cast derive macros. Wait, did I see? Hold on. Did I see? No, never mind. Fail to resolve derive macros. Can I do here? Use cast derive macros as derive macros. Does this work like this? It does. Okay, and then I do the same in cast then. That's how I rename. Use cast derive macros as derive macros. Abuse inference. Yeah, and then use cast inference as inference. I do that. Abuse inference. Rock macro panicked. STD. Cargo manifest dir. Can I do here cargo workspace dir? There's such a thing? Hello? Why can I not paste here? Paste. Wait, what? Oh, my Firefox is broken. What? Hello? Firefox is actually broken. No signal. Nice. Did you make this with shame? Tell me you made this with shame. Base. There is no workspace. Okay, so I need to have the relative path to the cargo manifest there, which is going to be cargo manifest slash dot dot slash dot dot slash std, right? This is for embedding the cast standard library. Okay. No, you have no time to even use shame. It's such a shame. Virtual workspace defaults resolver 1 despite one or more workspace members being on edition 2024 and implies resolver 3. Okay. Let's do here workspace resolver is 3. It changed the version of sin, it seems. Fine. Okay, so if everything compiles, we do just check compile times. Let's see if this changes everything. So all I did is I split the main crate into 2 crates, cast and cast bin. So I should now see the separate timings, right? And then I will want to split other things, like the JavaScript transpiler probably can belong into its own crate. I think interpreter compiler, like this is more difficult though, because yeah, I could do some things here, but not that easy. Good morning, gatherer. What about examples? Examples don't work in the workspace, right? Cargo workspace examples. How to include example projects in workspaces. Examples don't have manifest files. Can I have examples in a virtual workspace? No, not D language. Let's just do the new one. Can I have examples? Virtual workspace, Rust. Binary library. What? There is no examples here. I want to have examples. That's not examples. That's the example of a workspace, not examples in a workspace. Shit, we failed. Hold on. Compilation failed. Why? Rusty line is not there because the binary. Okay, so the binary doesn't compile. This thing still takes 58 seconds though. So this is literally the same. This doesn't change anything. Type checking still takes 20 seconds, right? Which makes sense, I guess. I just need to make sure that the rusty line is there. So cast bin dependencies rusty line. Is this? How do I? So like I also need to make sure that this is not the dependency of the like this is not a dependency of the library actually, right? So and like clap also is not, right? So I can I see the unused dependencies? Cargo UDEPs, right? Is what I need. Find unused dependencies. One can compile and run cargo UDEPs on the stable compiler. It's cargo UDEPs here. It is. Okay, how about I install it? Like that, cargo UDEPs. Compiling cast. Privacy checking, lint checking, module lint, coroutine obligations. What's that? Borrow checking takes 2 seconds. Borrow check-in takes 2 seconds. Is that a lot? I mean, that's not bigger than 24 seconds for the type checking, but I don't know. Ah, shit, okay, there's still something. Color iris still is a dependency. Color space, true. Can I have, just cargo build? Rust analyzer, stop. I didn't tell you to start. Oh, and cargo build doesn't even, like, it still starts from scratch because I do the Rust flags. Oh wait, but oh, hold on. So I have this thing, right? I have Rust flags is Z time passes. But what I can do is I can do cargo Rust C workspace. Cargo Rust C just invokes the Rust C once though, right? I don't build the thing. Like I want to only pass the Rust flags to the crates in my workspace, right? I guess that's not possible. Cargo Rust C help. Because I know that Cargo Rust C only passes the flags to my workspace crates. Build all examples though. All target. It just doesn't have the workspace flag. For some reason. But it can be invoked multiple. Yeah, whatever. Okay, fine. Let me just do... I just comment the cargo clean here. Maybe I have a separate one. How about this? Cargo. Just check compile times. No clean. Like this. Cast AST. Wait, why am I dependent on on cast AST? I feel like wait, where is that? In the REPL helper? What about I do cast ::AST and I will just re-export that from there. It's already re-exported, nice. Okay, something else. Temp file, of course. Is there like an easier way to split my code into multiple crates and also like bring the dependencies automatically? I guess I could just copy paste all the dependencies, right? Just all of them, and then like do it the other way, like remove the dependencies if I'm not using them. This time it's futures light, for example. Let's actually do this. Let's actually do that. Yeah, there's probably like also console error panic hook, probably also belongs to the binary. I think. The only extra dependency is the cast itself, basically. And then we just remove them with... yeah, there we go. It's done. So then we just remove them with cargo UDEPs. Cargo UDEPs is not working with Resolver 3. Wait, what? Cargo UDEPs version? What's the most recent one? Maybe cargo UDEPs. Repository. What's the latest version? 0156. Yeah, it's not the latest one. 0156. Okay, let's just update everything then. Including Rust. Fine. Let's update everything. So this is just me. Split cast into cast and cast bin. This. It's going to take time though. Could I just update one thing? I guess if I can just update the Nix packages, not the Rust overlay maybe, but it will probably do the same. Right. I mean, it's not that bad, it's just downloading 20 megabytes. Right? Building Rust nightly. I imagine there's going to be a lot of waiting today. Let me just plan for the future. So what am I going to do? So here's my library. I need to split library into other crates. What can I split into the crate? I guess does it make sense to split the definitions of the types into its own crate? Like, what's the type? What's a value? What's like, yeah, maybe it does, right? Maybe it does. But then the question is, so like I have, like, for example, inference. Inference is implemented. You've seen WGBU do something like that? I have inference in its own crate. What would make more sense? Have the inference depend on the types so that the inference for types is implemented in the inference crate? Or can I have the or do I make my types depend on inference and implement the inference for types in the you know, in the crate that describes the types? Which direction of the dependency makes more sense? Maybe have everything about the inference in the inference crate makes more sense. So this trait is defined and implemented in that. Like, it's just like that. The problem is that the inference engine is kind of like generic. So it can work with anything, not only with my types. You can use it for your own language if you wanted, kind of, which is nice right now. And if I do that, then that would be weird. Cargo UDEPs. Wait, what? It still isn't. Okay, why did I even update? It still is not there. Cargo UDEPs version. Wait, this is 148. Wait, what? Am I not using Nix packages unstable? I am. unstable 0.156. Wait a second. How does this not, how did this not update this thing? Who knows Nix? Is this unstable not from the is it not Nix package unstable but just unstable? What is this corresponding to? Nix search, Nix packages, cargo depths. 0.155 here, right? So it's already different. Whatever version I'm using here. So it's the branch, or do they use the master branch here potentially? Let's see, Nix packages, unstabler, like it's more unstable, I guess. Let's do that. Let me just try to download one dependency from a different branch, maybe just unstable something. Something like this, and then I use the cargo view depths from packages and stabler. Unable to download unstable. Yeah, this doesn't exist. What are the different branches there? Like just master? I mean, yeah, it is more unstable. This one has some this branch has some tests on it. The master branch is like it's not supposed to be used. I'm just wondering, what is this search corresponding to? Is this for the master? You're on the right branch. What's the issue? Like on the NixOS search, I'm searching for the package. It says 0.156. But if I just updated my Flake, and the version of the package that I installed said a different version. Oh, Spike. Here's my Flake lock, right? Nix packages. Revision is this. So we can look at Nix packages. The branch, Nix packages unstable. The latest commit. Where do they show me? Like over here? 5395. This is the commit. This is the latest version. Did I Nix develop again? I'm pretty sure I did. Maybe I didn't, you're right. But I'm pretty sure I did. Cargo UDEPS version. Like, okay, Durant reload, sure. I mean, I'm using Durant, I'm not developing. Yeah. Wait, this is from master. This is supposed to be from master. Hello, Harry. Alright, now we're nixing instead of like doing the Rust. Hold on. Nix packages, let me see. Packages. How do I find a specific package here? We go here, source. Meta is this. Version 0.156. Fetch from Git, revision, V version. So it's supposed to be correct. Classic. I don't know, this looks correct to me. I must understand what's happening. Never bothered with Nix yourself? Nix is nice. Except when you need to like dig into things and why they don't work. Otherwise it's very nice. It's like specifying the dependencies that are not just like that are the binary dependencies in order to work with my project here. So like in order to work with Cast, I need a Rust and Rust analyzer. I'm using Cargo Flame, like I'm using Node.js because I'm transparent to JavaScript and everything, right? And like having this as just declared like that is very nice. So I don't need it to be installed on my system. I just go into the project and then it's just installed here. I can myself to use it to manage my entire desktop environment. Yeah, maybe. Yeah. Weird issues. I think it's me not understanding something. I don't think it's a bug. Like, but judging by all of the hashes, I should have the oldest version, but it's not. Like the newest version. But it's not. I can do something like this. Let's just copy paste this code. How about I just copy paste this code? The fact it's not easy to figure out what the issue is. Yeah. Yeah, Nix could be better for sure. I wish someone makes a better Nix. Some point. Like, just there is no alternative, right? The only alternative is working in the... I guess Dev Container is another alternative. You can make a Docker container with everything installed, basically, and then work inside the container. Doesn't really work with the GUIs, though. Like, I cannot do that with when developing my game. UV? What's UV? UV. What's UV? Extremely fast Python package and project manager? I'm not using Python, right? All right. How do I figure out what's wrong though? Let's see. Let's see. How do I exposures unstabler? Packages make shell with packages unstabler cargo udeps. Yes. Hold on, let me do this. How about I make a new one? How about I make a new one? Let's do a test. Test flake. Hello? I'm trying to paste into Vim and it's hanging. My Vim just hanged. Is that normal? When I try to copy paste my flake into it? Hello? Wait, what? Why does nothing work? paste into Flake Nix. Can you do that? Wait, I cannot do that? Wait, hold on. What do I even have there? What do I have in my thing? I think my... Oh, I remember. Yeah, like I was trying to copy paste something into the Firefox and it didn't work too. I think I have an issue with my... No, I think for some reason my copy paste button doesn't work. Like if I do Control C and Control V inside of this, then it works. But if I do try to Control V over here, for example, then it doesn't for some reason. Yeah, and it makes the Firefox also hang a little bit. So there is something wrong with my copy pasting. What? That never happened before. Classic Linux issue. Now we debug Linux and copy pasting. Okay. Okay, I guess I can just do copy like this. Copy project Astlang cast flake nix dot. Okay. Let's do that. Fine. So I just want this. I just want this. Nix packages. Like that. Systems, packages. I don't do cast. Packages. I just do the dev shell. Like this. And Rust overlay is not needed. Packages. I just want the cargo UDEPs, this specific one. That's the only thing that I care about. Okay. Nix develop dot cargo UDEPs version. Cargo UDEPs version. Oh wait, hold on. I think I understand why. I think I understand why. I think the reason it's different is because it's installed in my home home.cargo bin. Yes, I have the cargo UDEPs here. I need to like remove this basically because I don't want it to be managed through cargo install. Cargo uninstall cargo UDEPs. Like I want, yeah, this makes sense now because it prefers those binaries, right? Can I just remove all of these? Wasm bindgen. Yeah, I think I just remove all of this. Cargo bin. Cargo UDEPs version. Okay, there we go. That makes sense now. Or that Nix would not set up paths to prefer local bins first. It's not the Nix, it's the cargo. It's the cargo. Cargo is preferring the home always. Like, I guess like with what Nix, like maybe like through the Nix I can like patch the cargo so that it like doesn't look in my home. Maybe. It comes from your path. Path. So there's a bunch of Nix stores. I don't know. I don't think it comes from the path. No, it doesn't come from the path. Cargo bin. Like this thing is not there, right? Cargo comes from the path, yes, but cargo is installed through Nix. Cargo is not looking at the path. Cargo is looking at the hard-coded directory over there, which I don't want it to look at. Okay, anyway. Cargo home. Oh, I can just set cargo home? Cargo home. Yeah, maybe if I set the environment variable cargo home, it will not. Cargo home functions as download and source cache. Yeah. So like if I do cargo install, it will install there. It defaults to home cargo. Can I make it be like dev null? Or will it break cargo? I mean, there's the registry of downloaded crates. Yeah, I mean the downloaded crates can live there. It's fine, but I don't want the installed binaries from there. Yeah, this means that I can share the downloaded crates over all of my projects, which is fine. All right, dependencies: async notify, clap, color IRI color, draft map, rusty line, temp file, and tracing subscriber are not used. Let's go there and remove the unused ones. Async notify, clap, color IRI colored, tracing subscriber, temp file, rusty line. Ref map. Async notify. I already removed that. Okay. Can I also have... Wait, can I have these things automatically sorted in my cargo toml? Is there like a sort toml thing? Sort dependencies. TypeScript, pylons. Nah. Cargo, sort dependencies in cargo toml. Cargo sort, a tool to check that your cargo toml dependencies are sorted. We can have a tool like this, sure. There's an RFC to split the two. The cargo home refers to both the cache and the bins. Yeah. Hello, Nigel. Cargo add does not maintain the order. What do they say here? Like this is closed as not like planned or something, maybe? Cargo add preserves sorting when it exists. And that's a built-in command, which knows about the ordering then. Town. But if it's not sorted already, then I need to do the cargo sort. I would care about sorting. Dependencies should be a DAG. That's what I was actually talking about. Yeah, maybe like I want maybe the sorting, but in the form of a DAG. Actually, I want topological sort, not the alphabetical. Probably, you're right. That's what I was talking about. I want all of my crates here in the file viewer to be listed in the topological sort too. I cannot even like manually sort the file viewer, right? Just want the crate graph, which is provided in the rustc. Yeah, but like that means invoking a tool and looking at it. When just like reading code, I don't know. I feel like it would be nice to just. All right, we do the push-ups. Fine. Hold on. Done. Yeah, maybe just install a cargo sort or something. Or anyway, let's do that later. Cast bean doesn't depend on async notify. And ref map. Add a linter that only lets you include files lower on the alphabet. Do you want to compile it in order or just list them? I mean, it's automatically compiled in order. Like over here. Right? All depths seem to have been used. What if I have like a workspace dependency? Like, you know, because I have a workspace and my dependencies are like the concrete versions are listed here. Can I make a dependency that is actually not used? For example, shame. Will it be able to see it? All dependencies seem to have to be used. Okay, so it doesn't like actually look at workspace dependencies.
Hello, Pew.Apomin.
Pew.Apomin, hello, hello. Makes me sad I didn't get that name. Oh, that's right, I used the wrong crate too. Alright, fine, we'll include you here. Okay. Remove unused dependencies. Okay. Let's install cargo sort while I remember about it. Cargo sort. Oh wait, hold on. Unstabler. Still doesn't exist. Cargo sort. No file found at cast creates cargo toml. Is this thing stupid? I think this thing is stupid. It's trying to find the package in creates cargo toml. The reason for this is probably because I have a workspace members to be all crates in the crates folder instead of listing them explicitly here. All right. Is there a better cargo sort? Or maybe I should, you're saying it's a user issue? Wait, hold on. Cargo sort reports no file found at when there are dots in directory path. Do I have dots? No, it's not about the dots. Cargo sort is dead. Use cargo sort fix instead. Hold on. What is this? So the maintainer of cargo sort is incomprehensibly silent. Oh no. Is this the war between the crate maintainers? Are they like talking like this about each other? Okay, well, I mean, is there a cargo sort fix in Nix? The sort wars. Cargo sort fix is not there, no. Undefined. Well, I mean, I can patch it, I guess. Let me remind myself how to patch. This is just a fork. Wait, it's not even listed as a fork. Is it just copy-pasted? Five hours ago. This one, like, did something. This one has 1 star, though. I don't know. Not used by anyone. I mean, I could install it. I could provide the way to install it. All right, maybe I just don't care about sorting my dependencies. You know what? We just don't care. Oh, 10 out of 10 sounds like a virus should install. Yeah. Okay. Let's continue with the compile times. For anyone who is just joining the stream, I have a problem with compile times a little bit. My Rust is a little bit slow to compile. Let me show you. We're going to compile everything from scratch. And basically, all of my dependencies, this is my programming language. All of my dependencies, they compile in 8 seconds, and then my code, my main crate, it builds in 1 minute. 45 seconds when I'm not streaming. I guess about 50 seconds on stream. So we need to do something about it. Didn't start building it yet. You can have coffee break every build. Yeah, I can. Fine, I'll go and get myself something to drink, actually. Do I know why it's slow? Yes, I know why it's slow. So like here, over here, I'm using, I'm trying to profile it, right? What is the time that is used? So for example, over here, I was compiling Rust line. This is my dependency, right? This one took 1.5 seconds to compile, right? Dependencies, they don't matter much because the dependencies that we only compile once, right? So this 1.5 seconds, sure, like maybe could be faster, but it doesn't matter, right? But yeah, here's my actual code, right? And it takes 59 seconds this time, exactly a minute, right? And it's not proc macros. That's why I was looking at this. It is not proc macros. Look at this. So parsing the code takes 1 millisecond. Macro expand, which I think is the proc macros, it takes 160 milliseconds. But then the type checking takes 22 seconds, 23 seconds. Monomorphization takes 21 seconds. Generate create metadata takes 23 seconds. LLVM passes is 10 seconds. Code gen is 10 seconds. But mostly, I guess it's the type checking. I'm just using the types a lot. All right, maybe I can refactor something, but I think that what I should try is just to see if splitting the crate into multiple crates will like help. Potentially, for some reason, I don't know. I mean, it will help if I don't change the other crates for sure. Like if I don't change, like, you know, it will help with parallel builds, and like it will be more incremental that way. But I'm just wondering if it's going to reduce the time for some other reason too. Is there a multiple 22 seconds job? But total is 59. They are a little bit in parallel, I guess. Yeah, I do like run this command with saying jobs 1, which is supposed to like remove the parallelness in order to like profile the compilation. But yeah. Oh, maybe over here I can like clean my things. You know what? How about check compile times from scratch will be the full cargo clean. But this one is going to just clean cast AST, cast bin. Like I just want all of my crates here to be listed, right? I do that. More parallelism, the better. Yeah. Sure, but I think that 1 minute though is still a lot. Like there is no other crate that compiles in that long, right? There is no way I'm like why is it compiling that long? It doesn't make sense to me. My code is not that bad, is it? Like what if like type checking is just not linear, but like the bigger your crate is, like it takes like quadratic time relative to your crate size, for example, for some reason. Okay, so let's start with the simple stuff. Or is it simple stuff? I don't know what's simple, actually. There's this executor, for example. I can move the executor into its own thing. This is very simple. It's just 100 lines of code. Does it deserve its own crate, though? Maybe not. But maybe I can move it into the utility crate. This is the executor. Async executor, and it's different from this async executor, from that when it spawns a job and the job results in a thing, the thing is then later stored, and I can get it by reference instead of like by taking the value out of the job, right? It just stores it somewhere, and then it gives me the reference to it instead of like it doesn't give me ownership of the result. Yeah, and the job also can fail, I guess. That's the thing. All right, we move it one at a time then. Fine, let's start with the executor. What step is taking long, compilation or linking? Compilation. I was just showing this. If you missed it, I'll show it again. Timings txt over here. This is the detailed compilation times. Wait, what's wrong here? Well, then try hash. Compiling, cast. Yeah, over here. So, yeah, I don't know, for some reason there is something else after that, but basically, so here's the crate that's compiled in 60 seconds. 22 seconds is type checking. 20 seconds monomorphization. 22 seconds generate crate metadata. 10 seconds code gen. 10 second LLVM passes. Yep. Cast executor remove move utility lib mod executor like this. All right. Expected 3 arguments found 4. Async 1 cell. So we now have async 1's cell. Workspace is true. Like, should I also, like, I could also split the utility crate into its own things. Like, all of these can be its own crate. All of these modules, technically. But this is not the bottleneck, so I guess I will not do that for now. Box future. Alright, let's see. Use futures, prelude. Futures. Async executor. IRE. Async one shot. Pad adapter. Matter X. Use create pad adapter from matter X. Arc use create arc. Oh wait, box future is not there. Use is not in the prelude. Future box future. Erasing an IRE. Will splitting into different crates really help give you a significant boost? Well, at the very least, it will help if I don't touch specific, like for example, executor over here that I'm moving is a dependency that is the code that I don't touch. So if I don't touch the code, it doesn't need to be recompiled. Right now, basically the entire crate gets recompiled, which hurts the compilation times. So this makes it more incremental, and will make me only recompile the parts that I actually change. Cancel running fly checks, please. Oh wait, cancel running is not this. Toggle fly. Disable check on save. There you go. Oh, it actually disabled it here? Okay, sure. Whatever. Like, for now, I will do that. Okay. So now this mod executor doesn't exist. This will be not self-executor, but util executor. Other than that, should all be the same basically. But this should not change anything. Check compile times, just in case. Just in case a moving executor like removes a couple seconds from the timings. Like, it shouldn't. This is the smallest thing ever. Seconds. Yeah, if it removes like half a second, it's probably like already like the like half a second, maybe even a second at this point is like the error. Like several like different compilations can take 1 more second easily. All right, so this is move executor into util. Done. It's literally the same. Okay. What's this other thing though? I don't get it. There are multiple things here. It's like I'm compiling something in parallel here, which it should not happen. Okay, what else can I move easily? Can I easily move like the JavaScript transpiler, for example? Right? Can I easily move that? So this means that maybe the thing should be something like something like that. Right now we have like the library, the binary, basically. This is the only thing, right? I want to split the library into multiple parts. But the library should contain the JavaScript. So like the library is like something that is collecting all of the things together, right? So let's say that over here we have the JavaScript compiler and like some other parts, right? But the JavaScript compiler like depends on some other part of this library. So like maybe we have something like the core, and then like we have some sort of like a plugin system somehow. First time you've seen Sprite used as a whiteboard. What else should I use as a whiteboard? I was using Paint before when I was on Windows. I tried developing a game with Rust, but honestly, the compile is such a waste of time at this point. Is either get GigaChat Intel processor or consist you with C++ or Python. Well, C++ is worse in my experience, at least. I mean, with Bevy is bad. Okay, sure. But maybe if you compare to Bevy, then yeah. But yeah, I don't know.
You can just try some because the alternative that you're using in C++ is like very different from Bevy. You can use something close, some libraries that are closer to what you're using in C++, like something simple. Like if you are using in C++, for example, like Raylib, then maybe you should use something similar to Raylib in Rust that will compile faster too, like Macroquad, or like the Raylib itself, the bindings to that. Macroquad was fast but still slow. Yeah, like if you just bind, like especially if you bind Raylib as like a dynamic dependency, that will be like, I guess, even faster because you don't need to compile it at all then. But yeah, I think something like this is what we should have. Because if I look at the JavaScript, right, what this does in the end is it implements the method on the cast itself, right? So we have code like this. We have struct cast, impl cast, compile to JS, like this. Right? If I move this into a module, right? So like, let's say that this module is actually a crate JavaScript, right? So I will have something like more like core, where we have the cast core, and then in the final library, like the cast itself, we will have cast, which contains the core, which is core cast, and also like whatever state is needed for JS. I mean, like, I don't know if this is part here, but basically we then have a, like, we can have a function like that, which is just forwarded to JS, compiled to JavaScript. I mean, I can have this as a standalone function there for sure, if it only depends on the core like that. I don't know, I like having it as a method though. But yeah, I guess it doesn't really matter much. This one is easy because it's just like a standalone thing. But if I have something like, let me see, what else would I be extracting here? Let's take a look at what is in the cast right now. The cast right now has the syntax, has interpreter, and has the compiler. Because compiler is the interpreter, I don't think I cannot like split these two together, split this completely. I mean, technically, interpreter does not depend on compiler. It's the compiler that depends on the interpreter in order to run compile time evaluation, right? So I guess interpreter can go into its own crate. Inside of the cache, I have just some stupid stuff. Sometimes I feel like we need a dynamically typed language, but good. Wait, what? What for? Why do you need dynamically typed language? Oh, because the type checking takes 20 seconds, that's why? Yeah. And like, if I want my type system in my language to be even stronger, like if we add dependent types, that actually hurts the compilation times even more, because basically type checking means running arbitrary programs. there's a room to explore in that space. I don't know. I mean, I have the interpreter here. It doesn't make my language dynamically typed though, but it also means that I can run code while the type checking is still going. Like, so like the way my language works is basically, in order to interpret like a specific piece of code, like I only require the types to be inferred like for like at some places, but not everywhere. Like I can literally run code that is not inferred. So like type inference and interpretation can happen in parallel. I don't think, I don't know like if any other language is doing that. Invent a new buzzword, hierarchy. Yeah. Well, I mean, technically, like, I think maybe they are doing it correctly. Saying hierarchy or something instead of saying linear types. Because, like, when you say linear types, it's like saying a monad, you know? You say a monad and people are scared immediately. You know? Like, that's why I don't want to call my stuff, like, an algebraic effect system, for example. We call it a context system instead. Right? I don't know, like Rust, for example, calls traits instead of type classes. Or, I don't know, like Rust also doesn't really like teach you like what's an affine type, for example. It just tells you that there is a borrow checker. I feel like there's a better example in Rust that they like they have names. Like algebraic data types, Rust just calls it enums, right? Because it's a less scary word. Although I think in that sense, like C++ has better naming. They call it variant types, right? And that's what I call them myself. I think variant types is a better word than enum. But yeah, avoiding scary words, I think, is a good thing. Although, at the same time, I think Rai is a scary word for people who are not familiar. So, like, I don't know what is more scary, actually, Rai or a linear type? Like, higher Rai or a linear thing? C++ calls the whole thing variant, not the individual variants of the enum. Oh, no, wait, hold on, no, I actually, no, the C++ calls them not variant types, they call them choice types. I'm referring specifically to the safe C++ proposal, I think, right? They call it choice types, yeah, over here, choice types. They had, like, the variant in the std is a different thing. This is, like, the actual, like, enum from Rust. For an enumeration whose underlying type is fixed, the values of the enumeration are the values of the underlying type. It's possible to define an enumeration that has values not defined by any of its enumerator. What? I'm not going to read that. You treat that proposal as it was as canon? Yeah, I mean, I just remember reading that and remember that I liked the choice of the word there, the choice type. Choice variant, I don't know which one is better. I just don't like the enum. Enum is like weird. Okay, I was looking at this. Exec mode, run import. Scopes. Compiler. Okay, let's just start with by extracting the JavaScript. JavaScript. So how do I do that? Oh, wait, hold on. I realized why cargo sort didn't work. It's because I am currently in the folder called cast crates. I blame them for no reason. It just doesn't look for the workspace root here. Let's install back cargo sort. Discriminated union. I don't like that name either. Tagged union is a little bit better, I guess. But I don't know. It also overloads the enums in Rust, where they are both ADT and actual C-like enums. Yeah. I guess. Well, I mean, it's like a CNA enum is like a specific case of the enum where each variant doesn't have any data associated with it, so it's not really a different thing. Cargo sort workspace. Look at this. It actually sorted stuff. Nice. But it kept the blank lines. Where does it? Okay, I don't want all of them to be sorted actually, because they were grouped. I was having groups of dependencies here, like internal dependencies, external dependencies, and other things. Undo everything. I regret sorting now. Why not use enum? It's only a proposal and not officially part of the language. It's okay to say that C++ does not give you a choice. Yeah. But why not use enum? You say like, why not use enum as a word? Because I don't like the word enum. It's like enum is short for enumeration, but I'm not numbering anything. I'm having variants, right? That's what I'm having. I'm having a choice, so I call them variant types. Like I'm not numbering anything. I don't care about the like which one is first and which one is second, which is what you do with when you are enumerating things. Use Taplow for formatting TOML. A binary or like an extension. I mean, my TOML is formatted. My TOML is formatted. I think. So I have this even better TOML, right? But they don't have the sorting. It does format it though for me. Doesn't have the sorting though. Or maybe they should have sorting. Sort. Feature request sorting. Not sure I understand what you mean by highlighting, but would using the following Taplow. What's Taplow? The TOML toolkit. Looks like the same icon. Feature rich TOML toolkit. Yeah, yeah, it is called Even Better Toml in VS Code, so I'm already using that. Formatter options. Sort. Taplo. Taplo sorting. Oh, I was already there. Yeah. Formatting reorder. Oh, it's called reorder. Hold on. Reorder. Alphabetically reorder keys that are not separated by blank lines. There you go. Alphabetically reorder array values that are not separated by blank lines. Reorder inline tables. Reorder keys. Taplotoml. Alright. Formatting, I guess. We can have auto-completion there too. But then I need like the command line for it too, right? Which there is. So that I don't do it from like it's both like VS Code and that then, right? Try to format with VS Code. Yeah, we can try formatting just to check. Like over here, right? I do Control S. Format. Didn't do anything. This didn't do anything. I did have the auto completion here though, which means that it's like supposed to be supported, right? Maybe it's not supported here. Maybe like not in the workspace dependencies. Maybe like in these dependencies. No. Taplodef in Nix packages. Yeah, I mean, but shouldn't VS Code also work? And you configure Taplo extension via VS Code. Oh, because this is for the okay. Configuration. Oh, this is configuration for the CLI. Search the kind for Tableau configuration file. Taplo. Bundled config file. Enabled. Whether to enable the usage of the Taplo configuration file. It's checked. Right? I don't want the custom configuration file. Let's try without a dot. Maybe. But it's supposed to be both, right? Oh, so okay, it's without the dot. Without the dot. For some reason it works, but with the dot doesn't. Although the documentation said that both should work. Wait. Now it works. What? Oh, maybe because I didn't have any changes in the file? Maybe it only does it if I have a change? No, it does this now. Yeah, there we go. And it like sorts the ones that are not split by the new lines, which is good. I'll move this here. Because these are like my crates. Like that. Maybe I didn't save. I'm pretty sure I was hitting Control S. Alright. And then we can do Taplo. Format. Read-only file system. Oh, because, okay, it's trying to go into the Derenv. Tableau format crates. Did not go recursively? Like, it doesn't format. Creates util. Argotomo. Like, that works. How do I use this from command line? To do it recursively. I mean, I guess I can do the find or something. Find. Name. Toml. Cargo toml. Yeah, find is not looking into the Derenv. So I just do exec Tableau. And recognize subcommand. What do you mean subcommand? Oh, Tableau formats, right? Like this? There we go. Now it formats everything. Okay, nice. Nice. Oh, it's also sorted like these. Wait, I'm not sure if I like this. I'm not sure if I like this. I only want to sort my dependencies. I don't want to have the name to be in the middle of these things. Is there more configuration options? Why am I even doing this? I was supposed to work on the compile times. Configuration. Formatting. Options. Where's the list of options again? Bike sharing formatting is the definition of productivity. There's an exact example in docs. In docs of what? Where? Like over here in the introduction. This is the CLI. Binary releases, cargo. This is how to install it. Configuration. Validation. Formatting. Configuration file. How do you even go to the configuration file? Oh, like over here. Rules. Okay. The rule array of tables consists of what should be done. A rule formatting. So like the rule for all the files for the dependencies. Okay. By the default, okay, we just do this. I see. Discard. Rule. It's supposed to be like that. Or something. I mean. Right? I wish this formatter would indent the things. Because this is the field that is part of this element of the array. It's a little weird. I know it doesn't matter, but like for reading, because this is the whole element, right? This is not a separate top level element of the toml. Have a look if you can enable indentation. Like formatting options, indent, configuration file, formatting options, indentation, indent subtables, indent entries, and then string. Like I probably like the arrays, right? Okay, indent entries, subtables. Like what's the way I would like to even format this? I'm pretty sure like it's kind of weird. It's kind of weird here because like I wouldn't format, I wouldn't indent this at all. I wouldn't indent this at all if I didn't have like this thing here. Because if I just do indent the entries, it will also indent all of my dependencies in the cargo toml, for example, right? I'm assuming it will do this. I'll just keep it like that. Can I exclude here? Strength. Target. Like, why is it even looking there? There is no exclude, is there? Configuration file, exclude. It's the same semantics include and takes precedence over it. Exclude cargo toml. Okay, you know what? We can do crates cargo toml, and we can do this cargo toml. No? So it only looks in these places. It still looks in the Durenth. Why do you look there? Because that's probably the default. Hello? Maybe it's always looking there. Huh? If I don't include anything, it does that. It does support git ignore. Maybe it does support git ignore. Yeah. Maybe there's configuration option for it. No. Oh, look at this. Align entries. What's align entries? Align entries vertically. Entries that have table headers, comments, or blank lines between them are not aligned. I don't know what that means. Try the exclude global. Oh, but this is part of the rules, right? Include property is an array. Oh, yeah, it is a global one. Yeah, okay. Sure. There we go. That works. It would be nicer, though, if I could exclude the git ignored stuff. Alright. Dependencies should be formatted. So this only changed the dependencies. Can I have like a custom order for these ones so that they are always sorted in the specific order? Okay, maybe it's good enough at this point. I should move on. There's a PR a month old or so. Git ignore issues. A config flag to add git ignore. Reading git ignore might exclude. Move to ignore or ignoring files. Down. What, this pull request? Yeah, because it's looking for targets. Git ignore true, git exclude true, git global true. All right, formatting my cargo tomls. Wait, did you format this toml too? What's the difference here? Like a new line in the end, probably. It's fine. Okay. Now to the actual stuff. Remove the JavaScript. Actually, you know, one of the easiest things to do would be actually to... how about I just disable the JavaScript for now? What about this? Mod JavaScript comment. Check compile times. Like, because previously it was like 59 seconds, right? So what it's going to be now? Let's see. Let me actually add this to over here. To do use git ignore. Wait, it failed. Why did it fail? Oh, because JavaScript here, yeah, I guess like it could be like a feature, maybe an optional feature. Yeah, let's actually have it as a feature. That's right. CFG feature is JavaScript. Features JavaScript. Cargo check. Okay, so this should only be done if feature is JavaScript. What else? This CFG feature is JavaScript. CFG feature is JavaScript. What's JavaScript doing in my language? It's a compilation target. Because it's a lot easier, I think. I haven't really tried yet. At some point I will, but I have not tried yet. To make like the native things. The reason JavaScript is an easier, I think, compilation target is because I don't need to look at types, right? When doing the native compilation, like I need to like figure out the sizes of things. I need to like figure out a lot of stuff. And because JavaScript is dynamically typed, it makes it very easy. Like also JavaScript has like closures, so I generate code almost like as is, kind of. I solved the lead code with it. We have the guess a number game in the browser. That's working. Okay, this is main. This CFG feature is JavaScript. CFG feature is JavaScript, and this means that we have features in the binary crate too. JavaScript is how do you do this in Rust? Deps colon cast slash JavaScript. That's how you do it? I'm not sure. Maybe just dep. Feature JavaScript includes dep Java, but with both dep and... Oh, dep is just like including the dependency itself, right? Just cast JavaScript. Okay. CFG feature is JavaScript. CFG feature is JavaScript. Here and there. Okay. Okay. Check compile times. Let's see now. If I don't compile the JavaScript, is it going to be better? I mean, I can for now. I mean, I was going to work on the JavaScript, so I mean, technically, I want to be checking this stuff with all the features. Still 22 seconds for type checking and 21. So like, wait, JavaScript doesn't change anything. 57. Okay, I mean maybe a second less. It was 59 and now it's 57. Maybe. So JavaScript doesn't matter. All right. Noise. What do you mean noise? You mean like, yeah, yeah, it could be just noise, but like it still means that it doesn't matter, right? If it shaved, if it removed a second from the completion time or not, it basically didn't change anything. In any case. JavaScript feature. Might want to ignore this. Okay, what else can I remove then? So I think the easy ones, well, like again, is just moving all the types into its own crate, like the type definitions, the intermediate representation definition, and to its own crate. Use traits and generics heavily, I guess, yes. I mean, even the definition of the intermediate representation here is generic because I have associated data, which maybe actually, like, I was thinking maybe I could try like changing that. So like, because if I have the data in every variant, maybe I should have like another struct which contains this thing and then like does that, but then it would still be generic because it would be generic over like the inner like thing. Kind of. I mean, not exactly. It just wouldn't contain self, I guess. Yeah, because these ones are just using the defaults. Yeah, I guess these generics could go away. There are tools that analyzes rusty time spent on different things. Yeah, that's what I already did. Which is why I know that my derived macros, for example, are not a problem. Here's my timings. I was just looking at that, right? it says all the different things. So I took 57 seconds to compile my library, 22 seconds for type checking, 20 seconds monomorphization. Some LLVM passes create metadata, but not the proc macros, which would be over here in the on the macro expansion. This is not self-profile. This is I mean, self-profile generated me some binary files, which I could do. I do time passes over here. Okay. Let's move the intermediate representation first, maybe. It's all very weird. Like for example, so intermediate representation kind of depends on the types and values, right? We need to like actually figure out the spaghetti of things, because an expression can, for example, can be a constant, right? And a constant has a value. Value can be a type. Type can contain a value inside, or a value can be an expression. So an expression can be a value, and a value can be an expression, right? So these types are already recursive. Type can contain values inside. So like, yeah, like everything is very highly recursive here. But I can move all of them at the same time, I guess. What would I call this? Like, what would I call this? Like cast intermediate representation, but it's not only about the intermediate representation, right? It also specifies the types and everything, just cast types. Maybe you can trade some generics for dynamic dispatch. Yeah, maybe. I'm actually wondering, like, I'm also using a lot of async code. I don't know if async is affecting it, but I cannot get rid of async. No, that's not possible. But yeah, dynamic dispatch and maybe like boxed futures. So boxed futures is like the dynamic dispatching, basically, of the async code. I need to box my futures a lot. Async traits or just async? Both. There's not a lot of async traits, though, I guess. But the entirety of the thing is async. But yeah, I think like making boxing the futures makes sense, because otherwise it needs to inline everything, right? And like it statically dispatches the futures, which is a lot of the generic code, right? I would assume maybe there could be some macro that automatically converts my async function into something that returns a booked future. Would be nice. Also, if I do that, I might not need to increase my stack size, and because I'm currently doing this, I'm currently overflowing my stack without increasing it. That's also because my types have a lot of like. I don't think like the size of the types affects the compilation time. Probably not. But like, for example, my let's take a look at how big my value is. Value is 160 bytes. That's not the biggest one. But intermediate representation, for example, right? The expression. This one is pretty big. 336 bytes. Boxing more things and using more dynamic dispatch makes sense. All right, cast types. Let's go. I'm just going to, for now, copy paste all of the dependencies here. Cast types. Okay, so what I move is value, intimate representation, and type. Maybe some other things. Mod this, mod this, mod this. Okay. This one is going to depend now on cast types. Yeah, let's actually just do that. Cast types needs a try hash. Can find substitute bindings. All right. Where should this be defined? Substituting the bindings in the types? It depends. Can always move it later. Yeah, I guess I mean maybe I will I guess like basically there is a trait that I need to implement for like the things, right? Right now the implementation was written right next to the type, right? I implement substitute bindings specifically, right? If I was doing it that, then it makes more sense to have this trait in the types too. So substitute bindings is this trait, which should also be moved here. Inference. Yeah, so does the type depend on inference or inference depend on the types? That's the question from before. But if I implement it here once again, then yeah. Oh wait, yeah. That's right. It's the type that depends on inference because the type can be potentially not inferred, which is kind of weird. Inference is type specific, yes. So like the inference crate itself is generic. So if I when I'm defining these types here, this crate should implement the inference for these types, right? Okay. Cast inference is a dependency. It's already there. use cast ASD, cast util, cast derive macros. Context. Context is also part of the types, I guess. We move this then. Here. Contexts. Maybe borrowed. This is a simpler version of a cow, which doesn't require the toOwned trait. This can go into the utility, I think. Mutability. 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 Places. Places also go there. Wait, shouldn't place be... Oh, yeah, this is the entire place. The entire place module needs to go into the types too. Names. Names should also be there. Name. I'm just going to move the entire crate like this. Why does toOwned owned sometimes not offer an owned version of self? Own does not offer an owned version of self. Sometimes you get reference to T. Maybe because you have a reference to a reference? So owned version of a reference to a reference is just a reference? But how is that owned? Well, it's the owned version of the thing that, like that you were taking a reference from. It's not like you still own the reference. You can own a reference, right? Like the reference is owned in this case. Previously, you were borrowing that reference. Yeah, like if you owe, if like a reference to a reference. Is that point of the trait is to make something static? No. I guess not. It's like the opposite of the borrow trait, basically. You have the borrow trait, and then you have the toOwned trait, which is the opposite. Like if you have a reference, then you can borrow from it itself, which results in a borrowed reference, which is a reference to reference, right? Trait inferable is not implemented for type shape. It's not satisfied. Trade bound is not satisfied. Trade bound inferable is not satisfied. Inferable is because like it's because I cannot even go for it, right? I need to use inference inferable. That was a bad message. Error message though, maybe. I need to look at the top of my error messages in this case, right? With context, yeah. So I need to use IRE wrap error. Okay. Use futures prelude. Lifetimes don't matter. Don't match. This is a lie. Why don't you? Why do you say to me lifetimes don't match if it's just the async trait is not imported here. Cast is not found. That's right. Because substituting the bindings requires that I have this thing. Okay, I guess substituting bindings need to be not here. Why does this work? Let T reference to U32 as to owned is a reference. Wait, what is it? Function foo. Let T U32 S2 owned. It doesn't. Can I T is to owned reference to reference 1 2 3. It's the same. It doesn't tell me. Is there a way to figure out what is this thing exactly? I can print it, but then I need to actually run it. All right, I cannot copy paste. Insulin. STD. Any type ID of U32 S2 owned what was it? Not type ID. Type name. See any type name. A reference. Indeed. Because owned borrow self. Wait. This is a good question. Why is it like that? Wait, what? Because owned borrow self? I mean, yes, but like you can borrow. Down. Oh wait, because like yeah, no. Because like you're supposed to do this. Um yeah, this gives you a VEC. Oh, wait, hold on, this is a different one. Hold on, no, never mind. Interesting. You expect something like box. Yeah. Yeah, I guess like over here, like it cannot give you this thing directly because this is unsized type. But then like, and it just doesn't choose it for you. But shouldn't this implementation just not exist at all for slices then? It's just implemented for things that are cloned, right? So like it's because of this blanket implementation, which makes it weird. Because like you can clone the reference, so you get the reference back. Yeah, actually, like you implement this for the unsized types, right? Because yeah, you implement not for the because you call it on the reference to the type for which you implement it. Yeah, that actually makes sense. Yeah. That's why I was saying that you should you're looking for this, right? Because you're trying to convert to owned variant the reference to this type basically, and not the type itself, but a reference to this type. Right? You have a reference here. It's a little weird. Okay, substitute bindings need to be for now, I guess, over here somewhere. Let's have a module. Mod substitute bindings.
Hello, Dev9H nails you.
Hello. Devninja. Did it call you Dev Schnitzel something? I don't know what the TTS said. That's types. Okay, so substitute bindings over here is just so this whole trait is going to be here. And then in these places, I implement substitution for all of the things in this place. Oh my god. Let's just search for impulse substitute. There's a lot of things. Oh, but wait, hold on. But I derive the macro here because that's what I want. Now, since like the type itself is in the other crate than the trait, I can no longer derive it. What do I do about that? I make the proxy type to be able to parse the definition. This is annoying. Maybe I change the trait instead. Maybe I change the trait instead. Let's actually have over here mod substitute bindings. So like this depends on the cast. The way this can work. How can this even work? Why is splitting your crate into multiple crates so much work? Find in folder. Cast dot. So like for example, this one default output. This should be done in a different place, I think. So this is fine. A single context of this type. Why does this depend on cast? Because I want to spawn the executor. Yeah, so like I just need to have access to the executor here for initializing the inference. All right. Okay. Substituting bindings requires me having this. But this can, so instead of a cast here, I could have a function for substituting bindings that actually is this thing. So a reference to a symbol, or maybe even just binding, like just binding has a value basically, right? So I changed the trait here. But this also captures here this stuff. Why do I capture this stuff here? This is a constant. I think this should not capture anything. No, I'm not working on Rossi. I'm working on cast, trying to make it compile faster by splitting the thing. I mean, splitting the thing into multiple crates is also good because, like, less spaghetti, basically. We try to make it less spaghetti at the same time. Is their naming just wrong? I can't make sense of it. The two owned. I thought borrowed is not owned. It's a little weird. Indeed. Maybe. I mean, the weird part is the implementation of the to own for anything that is clone. Right? Like if you have t and you want to convert it to an owned value, like you just clone it. Because clone gets the owned value, right? I mean, it kind of makes sense, right? You clone it, but like if t itself was a reference, you clone it, you get a reference back. That's what's happening. Say, try own generalized clone to construct own data from any borrow of a given type. Yes, from a borrow of a given type. So like you gave the type, which is reference. So this construct the owned value of a reference, which gives you which just removes one layer of referencing, right? Yeah. Okay, so yeah, and then over here is copy. When I'm claiming the value from a place, I'm either copying or clone or taking it. This yeah, this means that so this thing needs to know if the type stored in the place is a copy type or not. Okay. And this is just me getting the thing. Yeah. All right, let's work on this then. Substitute bindings. Why can I not go to the definition of this? Substitute bindings. Okay, so this trait should not have cast. It should have instead substitutions. Maybe I like move the cache there at the same time. Does this make sense? Does that make sense? Or do I have two arguments here still? Like, so basically, I want to have the recurse cache and the substitutions, which would be like a mutable, which would be like a func, yeah, a dfn. We try to use the dynamic dispatch now instead of like impl traits, I guess, right? We have a dynamic function from a binding into optional value. Right? That's what I want. So like, do I want to substitute this with this value? Sure. A reference to then. It should be called to owned of borrow of. Like clone will clone the t itself, and although it takes reference to t, but this goes the other way around. It makes sense to say impl clone for t, but saying impl to owned for t doesn't make this much the same naming theme. Yeah. Well, I mean, yeah, I guess. Well, I mean, it's yeah. Yeah, let's forget about it. Forget about it. Okay, so we have this. Now instead of cast, we have the substitutions like that. Substitutions, substitutions, substitutions. And all the casts need to be substitutions. Like that. Beautiful. Box future. Use futures. Future box future. All right. Oh no, this is impossible. Wait, what? So I have a native function. Native function needs to know what the cast is, actually, yeah. Okay. So, like, because cast is actually going to be defined later in another crate, the only way to do this, because, like, unlike the substitute bindings, I cannot replace this with anything. This should be then generic over whatever the cast is. Over the final thing. Do this and that. But then how do I do the native this thing? This means that this depends on cast, which means that the value depends on cast. Okay, this is annoying. Actually, hold on. Let me take a bathroom break. Like, remember this other thing that I was talking about? I had a thing. GitHub Kuviman. Minicast. Right. Remember this? Minicast. This is what I need. We make stuff generic over the final thing. So we have this problem where we have recursive dependencies. Let's write a simplified example, which is what minicast was supposed to be about, but just so that it's easier to understand what's happening there. Is minicast here? It is. Let's have something else, like examples, test, like this. So here's the thing. Let's say that we have, so what we're having here, we have a native function, right? So this is a programming language. So we have a value, and the value potentially has a thing which is native function. Native function is a function that is implemented on the, basically on the outside by the interpreter. Right? So what is this? What should this be? Well, because like it's implemented, like for example, if you're using this as an embedded scripting language, you should be able to create your own native functions, which should depend on like which should be able to access the interpreter itself, right? So let's say that we have something like this: struct interpreter, right? Struct interpreter. So a native function. What is that? Trait native function. Let's have it as a trait here as an example, right? And then this would be just, for example, this is boxed in native function, right? So what is a native function? This is a thing which says like call self with like, because it needs access to the interpreter. And it potentially wants to mutate the interpreter state. Right? And the argument, which is a value. That's what we want. I have a serious question for you. A while ago, you came to the chat regarding your programming language, R2D2, and I was asking if it was okay to compile to JavaScript, and he told me it was more than okay, it was good to do so. Basically, now I'm doing my essay. I would like to refer you to like have a basis on my choice. What does it mean, refer you? Like, have a reference to me in your essay? Like, what do you mean by essay? Like, you are doing, like, mention my name? I mean, if you want to, and don't mind too much. But like, what are you doing? Like the, it's your final project, like in the university, right? Your, yeah, something like that, right? Sure. For high school. We're now officially a reference on language design. Is that a good thing or a bad thing? Yeah, he wants to blame me for all the choices made. Sure, you can blame me all you want for choosing JavaScript. I mean, you did make it work though, right? That's what you're saying. So you, for your programming language, made it work. You compiled to JavaScript successfully, right? And like, have you tried other approaches? Have you tried compiling to other things? Like, the reason I was saying it's the good thing to do is because it's easy, I think. Right? It's because it's easier to generate JavaScript than to do something low level, because there is more details there that you need to think about. That's the reason why I am doing JavaScript myself. Okay, anyway, so like we have this problem. We have the interpreter, and interpreter, we want this to be in its own crate. But the value, we want to be in its own crate. Value is potentially a native function, which depends on the interpreter, right? Because because native function is basically a trait. It's a thing, which when you call, you do that. You should have access to the interpreter, right? I mean, like if we have no access to the interpreter here, why is this bad? Let's have an example of a native function, right? Let's have an example of a native function. We can take a look at actual cast natives here. For example, a native function compile AST, right? Like there are some simple ones like adding two numbers together that doesn't need to have access to the thing. But for example, a native function JavaScript transpile needs to have access to the JavaScript, right? Although, I mean, yeah, that's, yeah. Right, maybe that's not a good example. Let's see. What is a good example? Hash map. Contexts. This means this just means that I need to know what my current contexts are, which is like another hidden variable. So like this maybe could have another argument for contexts. This over here is doing instantiation of a template. In order to know this is hashmap into iterator. In order to know what is the type of the handler, right? What's the type that I am yielding, because this is a generator. So I want to get the current context of this type. Yes. Instantiating a template. Although I guess instantiating a template doesn't it like instantiating a template self clone, right? Why am I doing this? This makes no sense, or does it? It should be using the captured ones instead. Which also brings me to the fact well, I mean, yeah, it is the instantiation. Yeah, I mean, I have the current like state. Yeah, it's weird. Like I'm pretty sure I need access to the interpreter to implement native functions here. There are states such as like what are the like imported files, for example, right? I cannot have the native function without access to the state. Although for some of these native functions, I guess I could literally use globals, but I'm trying to not use globals, right? So I want to actually have access to this, to the like global state. So native function potentially needs access to the current state of the interpreter. Yes. Yeah, we do need it. That makes sense, right? That we need it. Yeah, it makes sense. Like, for example, what if I wanted to have a fake... I mean, at the same time, I could do it when constructing a native function, because I can move it in, right? Yeah, and I can, like, capture it, actually. You know? Like over here, right? I'm inserting this function. This has cast, but maybe in order to construct this function, I need to already have cast. And then I move it into this closure. Do I use the actual, like... something that depends on the caller? Like on the call place of the function? Does that make sense? Like, it seems like... I mean, maybe I can come up with a way where this is not an argument, and then it's not going to be a dependency. This looks like a big refactoring, though. If I can do that. So let's pretend for now that there is no solution for me to remove this. So we have this argument, right? We want, right? We want this to be in its own crate, right? So we have the value, which is in the crate types, right? We for now just use the module, like, you know, final crate. Final crate has the interpreter, right? And then we have a module like types. That's what we call it right now. Module types. This one should use final crate like this. So like this should not be here, right? Because we are not, like, with the module system in Rust we can have cyclic dependencies, but with crates we cannot anymore. Right? So how do I remove this? What is my native function now? How do I remove this? What is my native function? The way I remove this is I make the native function to be a thing that is generic over the interpreter. Like, because we don't know what the interpreter is, we make it as a dependency in the form of the, like, generic argument. So we do that. And then this means that the value, because it contains the native function inside, is also a thing that is generic over the thing, because that's our dependency, right? We use it's like the forward declaring my dependency here. Value is dependent on the interpreter. So like in the final crate, we actually will have the value, which is going to be types. So value is going to be types value of the actual interpreter that I defined here. And that's how we can have cyclic dependencies, basically, in between the crates. But it means that everything is now generic, which might actually hurt my compile times even more than we are being hurt right now. But it does split the things into crates, you know? What would be another solution that I think another solution that I'm thinking about? What if the value was not an enum? What if I make trait value? Because the native function is something that can only exist if there is an interpreter, because this is the only thing that depends on the interpreter, right? So what if I define the variant, which is the native function, since this depends on the interpreter, in the interpreter crate itself, right? So I will have like yeah, basically I can implement a value for, so we have like the native function here. It no longer depends on this. What do we call this? I value? Like, I don't know. I feel like we have like the trait I value, and then we have something like actual value is like box din I value, something like this. You know, this means that this trait can still exist here, and then I can implement the value for like box din native function, for example. Right? Maybe this is better. Maybe I move away from enums and use the dynamic things. This means that basically I can have other modules that extend what a value can be, which is good, right? But then we no longer have the matches, and we instead have these things. So I now should have a trait. Like, for example, the interpreter has a thing which is called function evaluate. or not evaluate, you know, like interpreter can. No, interpreter cannot evaluate. Wait, what? What am I trying to do to say here? Like where am I matching on the value? Um I mean, I'm matching on the value, for example, because let's see. So one of the things that we have, let's call this yeah, one of the things that we have is a type, right? So we have type named something like this. So I implement value for type like this, right? And then I want to, yeah, but this is in the same, like I want it to be, let's say that the type is defined like, I don't know. Wait, hold on. No. Let me think about this. Where am I doing the values? Maybe it's better to have an expression, actually, right? Maybe it's better to have an expression. Because then we can have the implement interpreter function evaluate. This would take expression. And this returns a value, right? Let's have an expression here. And I'm guessing the expression would also be a trait instead of an enum now, and we use dynamic dispatch like this. So we have I expression, and then we have a type expression is boxed in I expression like this. So for example, one of the expressions that I have right now is literally native expression, which depends on the target, and target is sometimes interpreter, sometimes the compiler to JavaScript, right? So we have a struct native expression string, like you know, we just have like code here like that. Implement expression for native expression. So over here, for example, I want to know if this is a native. So basically we write code like I would be writing something like Java, right? We say if instance of, like, how do you do this, right? You say expression. So yeah, since this is dynamic one, we should also have the any trait always, right? So these are always any. And these are always any, so I'm supposed to like downcast them. Use std any. So I say expression dot std any. Why is it so difficult? Downcast t, where t is any. But I have din t. Attempts to downcast the box to a concrete type. Box din any. Wait. Why does that not work though? Expression dot downcast into a native expression. Box din. Huh? The method was found for box din any, box din any, box din any. Oh, yeah, it's only for box din any, literally. Wait, how do you downcast for, like... Okay, so, like, this is literally any. Oh, it's because... Wait, hold on. It's because I can cast it first, right? Expression is... So I won't have a box din any. Is expression. Yeah, like, yeah, I can first do this and then downcast. All right. Hello, Nerdsoul. Nerdsoul, remember my mini cast stuff? Yeah. I'm trying to split my cast into multiple crates, and it's pain. It's a big pain. I'm trying to come up with another approach. So this is the simpler, like, this is mini cast, right? We have the interpreter, and we have the types, and we want these two to be separate crates, so there should be no cyclic dependency here. Might as well just rewrite everything. I like, if this is going to work out, it means that I will rewrite everything, basically. But yeah, I'm trying to think if I can do that by having values and, like, basically instead of enums, having traits instead, and using, like, dynamic dispatch. Because that helps for some things, at least, right? Should have implemented it in COBOL. Yeah, so, like, you see, the problem is that I should have a value which is a native function. Native function only exists in the interpreter. So native function is a type of a value that should belong to the interpreter, right? So this final crate is the interpreter. This makes sense that this type of a value is only available in the interpreter. Yeah, it makes sense. Yes. So now in order to evaluate the expression can be a native expression. If I do the same for the expressions, there's, I don't know, maybe there is a better example. I'm just trying to think if there is a better example for this. What do we do with values so that I only have one enum instead of two? What can we do with values? That depends on something from outside here. I don't know. I don't know really. But yeah, if I evaluate an expression, which is a native expression, right? So I say something like this. Let's actually have a reference here. Can I do a reference like that? This is now mismatched types. Okay. Oh, yeah. I guess I can do just din any like this. There we go. And then I do dot downcast ref. Yes, there we go. So and this returns an option. So if let some expression is native expression, right? In this case, so this is my alternative of the pattern matching. Instead of pattern matching, we just try to downcast, right? Expression dot code is what I have then here, right? And then I will like match code as string, right? Because this depends on the interpreter. Like if this is you know, plus, then I will return let f box din native function is something. Would making value be struct value e expression din e makes sense? No, it doesn't, because that's no longer. Wait, what? Why does the wait, what? The value is dynamic expression? Or you mean like I value? But with the din keyword, you only can use the traits. And when you say e colon trait, then e is the concrete type that implements that trait now. So you cannot use it with the din at all. It does make sense. So I construct some native function here, basically, is what I'm trying to say. And then I return box new f. Mismatched types. Expected type unit found box din native function. Oh yeah, I mean return. Of course. Yeah, there you go. So this works, right? So I have a native expression defined here. This depends on the target. This is one of my targets, the interpreter. So in the interpreter, when I evaluate this, so I see that this expression is a native one, then I return this value. This is just how I construct. So this shows how to extend the value in the other crate. The value type holds an expression. Well, I mean, I have the expression as a value too, yes. In the language, so that we can hold it like an ASD or a type is a value. But not all of the values are expressions, right? An expression is just one type of a value. What else can it be? Like, I mean, I can show you. Here's all the values that I currently have in the language. I have unit, boolean, integer, float, character, string, list, tuple, function, template, macro, native function, binding, variant, multiset, context, AST, expression, type, syntax, module, syntax definition, unwind handle symbol, a hash map, a reference, or a target. These are all the things that there currently are. All of those are expressions in AST level? No? Well, once I have evaluated the expression, it becomes a compute, like it's no longer a value. Like a value is a computed expression. You know, like if you want to hold the AST as a value, then we have an option for that. Yes, but you do that only when you're writing like a macro, for example. Then you like, because you want to generate some code in order to like, so like the code that is generated is basically a value which is AST. So like it's just the code, not the actual value. That's the difference. It's not an enum. Let me show you my enum. All right. What am I even trying to like come up here with? I'm trying to come up with a way to split my crate into crates. Your enum is smaller? Wait, you have a smaller enum for like all the, I mean you have the intermediate representation on for yourself, right? Not the values. Like the AST basically. Here's all the variants of the AST. We have a reference and or assign, list, unwindable, unwind, inject, context, current context, unit, function, type, cast, is, match, new type, variant, make, multiset, use, recursive, if, then, constant, number, string, native, let, call macro, scope, function, template, instantiate, tuple, AST, read, place, target dependent, and type. Not even that big. Shaders are dumb. There's not much going on there. Well, I mean, but at the same time, I don't have, for example, things like, I don't have things like add or subtract in this AST, right? Because they are not like, but you probably have them. Shader 99% statements, not expressions. I mean, yeah. For in my language, everything is an expression, so. Oh my god, this is pain. What am I trying to do here? If like, hold on, maybe we'll look at Treymarch's code. But Treymarch's code is all single crate anyway, right? Is Treymarch writing better code? Shame. Don't. I know, too late. I already opened it. Shame. I mean, it's two crates. You have the derive too. How recursive is the front end from the back end, for example? Why don't you make these two separate crates, for example, and like the intermediate representation itself? All right, let me do the push-ups quickly. It was like that before, but it turned out to be annoying during development. Have it as a separate crate? Wait, why? The reason I have it is because I have like I actually have like cyclic dependencies. Shouldn't it be better during development? If you can have it as separate crates. It's better because why is it better? Like I mean what's the reason to go back from multiple crates to a single crate? I don't know. Configure out the proper semver of doing it. The way I'm doing it, like, so I have like so I have the workspace. Why don't you just do this? You have a workspace package which is with a version, and so every package in the workspace just have this version. So like you bump the version of all the crates at the same time. Like you don't handle their versions separately. Why do you, like, it's not necessary. Like, you treat it still as kind of like the same crate, I guess. Then the backend API change that is breaking will cause a major bump in the API that is user facing. But that's how it works anyway for you right now because it's a single crate, right? So what's the difference? The interface between backend and frontend is not public. Right. Right. I guess. But is the backend public at all? What's public? The prelude is public. Some parts of the backend and frontend are public. I see. Yeah, I don't know. Language. WGSL. Wait, weren't you supporting the GLSL? You only do WGSL now? All right. Integer. Integer X divides. Dividend. Type integer. Wait, this is just self. Is it not self? Oh, divides self by integer. U64, U64. I4 conversion. Oh no, this is the other one. Is there other integers? Where the integer is not self? What's PO2? What is this? Power of 2? You have all the power of 2? Okay. Nice. You don't even... you write this by hand? Small vec actual, small vec dummy. Dummy small vec implementation that uses a regular vec underneath to do the tests. Shouldn't there be a CFG test on this module then? Answer. Enum length starting with 2. Interesting. Even lengths. Interesting. I wish enums could have subsets. Yeah, I also wish enum variants could be their own types. Wasn't there an RFC for that? Enum variant type. Even variant types. Closing as discussed in previous comment. We discussed this. In the meetings, we decided we're going to close this issue, but not without a good helping of regret. We all agree that this is a common and annoying pattern in Rust. This gives you the ability to have type for an enum variant, but is annoying and inconvenient. However, we also feel that this is striking a fairly core part of the language, so there isn't anyone on the team who has the bandwidth to actively liaison this effort. On the other one other concern that was raised is that there are a lot of nice to haves here. For example, it might be nice if none didn't have a type parameter, but they cannot all be realized. The G none needs a size. We're not sure whether just taking a minimalist approach of adding a type for each enum variant, but not supporting sets of variants, GADTs or other niceties will land in a place that is better than the status quo or more confusing. Leaning on coercions and the like has a tendency to introduce sharp edges, and I am definitely concerned that we get this feature to a point where 95% of existing code works fine. There is some stubborn cohort that doesn't. It becomes an additional axis of complexity for folks to navigate. One possibility might be using a procedural macro to try and prototype some of the ideas. The workaround was wrapping the variant value with the concrete type. That's what I'm doing. That's what I'm doing. It's but yeah. I mean, I guess it could be like yeah, that's literally what I'm doing here. Not all the time. Yeah, sometimes. We also have scalar type number, scalar type floating point, and scalar type integer for all the subsets. Okay. Is there an example of a programming language written in Rust? Let's look at RAI. Embedded scripting for Rust. GitHub repository. There's a lot, but like I'm just wondering which one is relatively like. I mean the Rust itself, but Rust itself, yeah, I need like yeah. Rust itself splits the things, sure, but I feel like it's easier to do that. Like I need something that's interpreted, right? And then I want to see if they actually split it into crates, but it looks like they don't. These are all just modules. Wait, hold on. So they have the how much code do they have? Hold on, let me clone them. How long are they to compile? Gleam is also in Rust. Yeah, maybe we can. Yeah, Gleam is probably more used. Gleam doesn't have the interpreter though. Like, I feel like they don't. Like, it's a lot easier for them to split it like this. Like, it's about these native functions, for example. I don't know. There's like a lot of ways of the reasons for me to be cyclic. Like, once again, like the compiler is the interpreter for me, right? An interpreter can perform compilation. So we have this cyclic dependency already. I cannot have the compiler and interpreter to be like very, very separate. Although technically I can like make the compilation be available in the interpreter later. Like technically the compiler can depend on the interpreter, I think, and then later I make the other dependency as a like, because compilation during interpretation is basically like having a native function which can be injected later. Rock language. Does Rock have I don't know, a compile time evaluation, for example? I don't know. Like I probably should take a look anyway. Rocklang. Gleam. Wait, is Rock a good language? What if we just rewrite everything into Rock? What if we rewrite everything into Gleam? Is Gleam a language that's fast to compile? Like Gleam, I remember Gleam doesn't have traits, which is annoying. What about Rock? Rock has fast compilation. That's one of their focus points. Have you tried it? Okay, so they compiled in 22 seconds the entire RAI. RAI is just the interpreter. It doesn't have the compiler, right? It's... Do they even have types in the language? I don't remember. Let's see the timings here. But I mean, look at this graph. This graph is basically the same. So we have a bunch of dependencies, and then the thing itself is compiling for a while because this is a single big monocrate. For them, it's just 12 seconds, and for me, it's like 50 seconds. That's the only difference, right? How big is their code? They have 60,000 lines of Rust. Toki source maybe specifically. This gives me only 40,000 lines of Rust. How big is my code? My code is smaller, like it's twice as small, but it's compiling 5 times longer. Because I have a lot of generics, right? Okay, what about Gleam? Code. Gleam. Can we just build it with cargo? And that's it? Let's clone them. It's all the async. I don't think that's async. I mean, maybe it's async, because async, once again, is generic, right? Because async generates this struct which implements the future. So yeah, I have a feeling that maybe if you do async and then you box all your futures, like whenever you call an async function, you want to call like it should await a boxed like you should always await a boxed future, maybe. So that way there is only one implementation of the future, basically. Right? That matters. No, it's not, because like in order for boxing, we need still to generate all of the other implementations of the future trait, right? So probably doesn't really matter for the compilation. I don't know. Gleam. Cargo, build. Timings. Okay, so they have 465 crates in total. What is this? Rust embed. What's Rust embed? A file embedded into the binary? Derive macro. Folder prefix, include, exclude. What's this? Where's the documentation for it? Source hut. Rust derive macro, which loads files into the Rust binary at compile time during release, and loads the file from the file system during dev. Interesting. So you just derive embed, folder, examples public, and this is a struct, which is like a virtual file system. Okay, makes sense. Is it compiled yet? It's already compiled. 1 minute for the entire Gleam. This is the same compilation time as my language. Why did they compile Gleam Wasm? Okay, everything is compiled. Let's take a look. So there's a bunch of dependencies that were compiled, and then we have the Gleam core, which is compiling in 20 seconds. All right. So I'm only twice as slow as Gleam then, right? Now try Rock. Yeah, you can also see, like, this is the main crate, basically, and nothing else compiles in parallel to it, too. They also don't split it into crates much. Okay. Let's try Rock, fine. Rock. Where's the... yeah, there we go. Maybe there's just nothing I can do. Like, surely the Gleam guys would figure out something. I should just, I don't know. Is Gleam async? Gleam is probably not async, right? You see, you think if I remove, or if I move my language to not be async, it's going to compile twice as fast? What is the core? Test, images, Gleam bin. Compiler core, this one. Source. JavaScript. JavaScript generator. Beautiful. Where would I look? Async trait. This is just for HTTP. This is for CLI. Other than that, they don't really use it. Okay. Rocket written is Zig now. Oh, really? Is there a cargo toml here? There's a build Zig. Oh, they have a flake though, so I can just do nix develop. Might require a bit more. It's fine. They have a flake, so I don't need to do anything. I don't need to install anything. They install things for me. Rock. And then I just do what? Is there like a just file or something? Like, what do they run to compile their thing? Building from source MD. Using dev container, using Nix. Yeah, there we go. We recommend using Nix. You try to run cargo before installing Nix. Cargo clean first to prevent you from executing cargo. Okay, just cargo? Or is this like all documentation, maybe? Building. Use cargo build to build the whole project. So does cargo build invoke the Zig then? I thought it would be the other way around. But okay. Yeah, let's just download a gigabyte of dependencies here, including Perl and PHP. Whatever was downloading there. How much of this is written in Rust? Crates. Yeah, okay, so they are doing it the correct way, right? They are actually splitting the things into crates. Compiler. I mean, compiler is still pretty big, it looks. The rock compiler. I'm expecting this will be the longest one. Can. Oh, wait, cargo. Wait. Oh, wait, compiler. These are all still other crates. These are all of the separate crates of the compiler. The identifier is in its own crate. This is just a small crate which defines what is the identifier, which is basically a custom string type. That's the trick. I think that's the trick with like making Rust fast to compile. You move everything into its own crate, kind of. Replace mod with crate. Faster incremental at least. Yes. D9 modules. Yeah. The problem is like the cyclic dependencies. It means that I need to refactor. It's not that easy. Can someone refactor my my cast into crates for me? Nerdzel, can you do that? Mr. Claude. I mean you can try. If you make it work, then sure. Show me. I don't think it will be able to though. But I will not try. The whole code base vibed up. Okay, let me think about it more. Why am I even trying to compile other languages? Just to say that it's fine and like just continue working with slow compilation. But I mean, how big was Gleam actually? Gleam compiles twice as fast, but how much bigger are they also? Gleam is a lot bigger, right? It's like 10, it's 10 times bigger. It compiles twice as fast. Imagine compiling Rust C. We can try. Rust C is probably like Rust should be. Rust should be. Split into crates properly, right? Where's the Rust C source itself? Compiler, right? This one. Yeah, so these are all the crates that they have. Span is in its own crate, right? So like this is just... Oh, wait, what? Why is this so big? Why is Span so big? Because you want to have edit distance? Analyze source file? These are just tests. Is it still downloading? The Rust? Okay. So here's my previous like attempt at coming up with a proof of concept here, right? Let me just show you what I have done before. So let's say that we have a language. Let's say that we have a language which has this was more for extensibility though, right? This is more for extensibility, I guess. So we have like the core definition of the language, and the core definition of the language doesn't know what is the AST, right? This is basically the AST, right? All we know is that we should be able to evaluate it in the future. This is like the header file for the final thing that we combine together in the form of a traits. And then every module can define its own extension to the intimate representation, to values, and add some more context to the interpreter. And then in the final thing, we basically combine the different modules where every module specifies its own values, ASTs, and like stuff, and then we just combine them together into the thing. This means that for a concrete module, we have a dependency on the final like thing like this, so everything is generic. How is that not slow? How is what not slow? I'm not sure if it's slow. Like this proof of concept was to just be able to split things into into crates. So the core thing here is that we still have the cyclic dependency, but it is now between crates. We do that by having the dependency, which is cyclic, to be a generic argument. I don't know if that actually like that probably doesn't help, like, because we will need to instantiate all of that in the final crate, maybe. I mean, I could try. What if I try here? Cargo build timings. I mean, this is actually just modules and not crates, because this was just a proof of concept. So yeah. Okay. Cargo build. This is time to compile the rock. Hello, Infinite Coder. Ooh, interpreters. Where's Infinite Coder's GitHub? What's TrustLang? Wait, what? What is this? Two years ago. Rust with effect system and more accessible macros. Wait, what? 2 years ago? Huh? Did you steal my idea for the language? It's something never to be finished? Well, just like my language, right? Was this even started though? You only had parser and lexer. I guess you yeah, okay, fine. Yeah, we have a little bit more progress than just parser and lexer. Okay, bye, I'm doing trust now. Where's the actual language? Just Orca? This is compiler toolchain. Code reloading, JIT, debugging, interpreting, LSP, syntax highlighting, code completion, hover info. Comp time. Backends. All right, let's go here. Let's clone this stuff. It's 1 gigabyte of a Git repository. Okay. No Nix flakes here. By the way, the rock language is compiled in 2.5 minutes. Huh? Error for file Firefox. Version CXX ABI not found. What? Can I do something like xdg open? That opens wine. Okay, fine. I just need to do it outside of this thing, I guess. Alright, so this is the rock language being compiled. They have 1 billion dependencies. And then rock gen dev morphic lib rock wasm modules rock can rock unify rock can solo. Okay. Rock mono. Rock mono takes 23 seconds. Rock language server takes 14 seconds. Rock bitcode takes 48 seconds. And the build script... Oh wait, this is running a build script, I see. Okay. You're counting incremental builds? Wait, what? You don't need Nyx flakes, it's pure rust. Where do I get the rust from, though? Like, you're assuming that my machine has rust installed. Okay. Rust and LSP and things like that in your system flake. Sometimes I want to switch to like nightly rust and stuff. You could also use yeah. If you want to manage different rust versions, what do you do then? Then it's easier to do the rust up probably. But rust up is still having a like it means like that you're having assumption about or like you say that you're someone who is going to compile your language will need to install the compiler, right? Basically. I mean, just Rust is easy, of course. It's fine. Firefox. All right, this is the Orca. You compile the crane lift. Crane lift takes 13 seconds. RA is all the Orca, or what is RA? Rust analyzer. What's RA? So yeah, this is fast. All right, we can look at something else, or I can try thinking about how to improve my stuff. Ugh. Rust analyzer, run it and see what it is. You mean just do cargo run here? Status, crates for file 0. Great. Never mind, it's updated. Now compile Linux. Linux is not in Rust though. I mean, there is some Rust in Linux, I guess. I would expect that to be fast to compile though. Um, bleh. So I started splitting my code base into crates, and it's just pain. I'm not even sure if it's possible. Let me tell you what I'm doing. So like here's all of the values that the language supports, right? And I want, I guess, split the value into its own crate. But the value depends on the final thing, once again, right? On the interpreter. Why? Because one of the things that the value can be is a native function, and a native function should have access to the current like state of the like interpreter. So we have this as a dependency here, which makes it weird. It's one example. What other examples do we have? Can the function be a different construct from value then? But I should be able to store it as a value though, right? Which is why I was like thinking, what if, like I was doing that example, right? Where like, did I remove it? Did I remove it? Yeah, I removed it. If we have a module types, right, and instead of having an enum value, you know, ABC, we have a trait value, which is having some definition, and then the actual value is a box in trait, right? That way we can have a virtual. This way the values are extensible, right? Dynamic dispatch. Well, I mean, value itself, like enum is also a dynamic dispatch. It's just like a little different. This means your compiler will be slow. The only difference between an enum and this is the indirection, like to the heap, I guess. Other than that, an enum dispatch is also dynamic dispatch. Enum is not. It is. It is dynamic. It is at runtime checking what variant you have. Static dispatch is when you already know the variant at compile time. Right? It's faster because it is not having the interaction. I guess in general, like this is also storing like the vtable and stuff. It's like a lightweight dynamic dispatch. Anyway, I don't care about the speed of the runtime much, because we can also always just JIT, right? Later. Downtown. There are other things though. Like, let's say that I remove the native function from here, right? There is still things such as what? I was searching for it, right? Find in folder. Cast. Yeah, I was doing that already. Yeah, so contexts, this doesn't matter. This can be moved away. This is fine. Substitute bindings is what I started with, right? So substitute bindings right now depends on cast, but this should all instead have substitutions, which I think I already even started, right? Yeah, I have substitutions here instead of cast. That was what I was trying to do. Substitute. This over here needs the access to executor. Wait, what? Substitute bindings needs an executor? Why is that? Because this is a maybe compiled function. I want to yeah, because I need to wait for it to be compiled, that's why. But I can just make this. Yeah, hold on. So I need to await the thing to be compiled. But I guess this shouldn't be a method on cast. This should be just a method on this thing itself. And we make that thing async. Wait, I only see the substitute bindings all the way. Yeah, over here, claim value. When I'm claiming a value in a place, the behavior depends on if the type is copy or not. Okay, and that depends on the current like state of the interpreter, which holds the state of like what traits are implemented for what types, like the copy trait. So that's a dependency here. But this this method maybe, because like actually claiming this will only happen in the interpreter. So maybe this method belongs to the interpreter, so we just move this one. Although that would be a little weird. You prefer the no responsibility principle? If something bad happened, the cat did it, not me. Yeah, I don't like having responsibility either. But who else is responsible for my compilation times? I don't even have a cat to blame it. This is mostly about substituting the bindings. And then the native functions. And then the place claiming. But maybe, yeah, maybe just claiming should. Okay, you know what? Let's just remove this from the substitute bindings. Let's do this. What I already. Let's do this thing that I was already doing. Substitute bindings. Cargo check. Like I also need to delete some code so that my errors are. Also, yeah. So I want, yeah. I think the easiest way, instead of like changing this in every place, I want substitute bindings to actually have like a single argument, which is like substitute like context. You know, substitute bindings context, like this. And then we have a struct substitute bindings context, which has like these fields. Okay. And then we can have a lifetime here, sure. Or I don't do that. Let's not have a lifetime. It's easier. The code is easier if we don't have the lifetime. So I'm just going to have the box here instead. And the recursive cache is going to be owned by the context. And then we just have a mutable reference to the context. There you go. That makes more sense. So this just has context, substitute context. I thought the D in solid was dry. All right, a lot of replacement is going to happen. Substitution cache. This is just context like this. Let me copy this and then this is just ctx. Okay. That. 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 Native function closure. This was me doing it temporarily. The generic here is not, I don't want that to be here. But this depends on cast. But in order for this to compile, I will just say that cast is something like, let's just say struct cast. How about that? And then I will remove it later. So yeah, I at least have like relevant errors. So yeah, we don't have cache anymore. We have context, and context has the cache. Context cache. This and this are public. And then, so scopes. This means that a function as a value has captured scopes. Which means that scopes should be part of the types too, right? Okay, let's move them. Scopes. I think scopes can be moved. This means that we have hygiene. Where's my hygiene? Enum hygiene. It's in the compiler. We move it to types. It belongs to scopes, right? Probably. Then we need IDs. ID is this simple thing. I think this can even go to the utilities. Which is there already. I just make it be over here. AST, since values can be ASTs, means that I depend on the AST. So I should just use cast AST. Ordered float. Use ordered float. Mutex. Use std sync mutex. Or do I use futures? Or is Tokyo mutex? Which one do I use? Probably just std. Hash map. Okay, substitute bindings. We have a module, which is substitute bindings. So I want to use substitute bindings like that. Right now, substitute bindings needs the context. So this is substitution for the context. This has that ctx context data ctx. No field cache executor. Single. Yeah, so this doesn't need a cast. This needs an executor so that I can spawn it. This itself is not async. A single one of this type. All right, let's just have the argument executor, which is executor, and I'll just say executor spawn. Executor is executor, which probably should just be re-exported from the util. I'm fine with re-exporting both. Context. These things I feel like I will, like default number type, these things don't belong here exactly. Let's do CFG false module to do. This change adds 15 seconds to compile time. Yeah, if like when I finish this, it's going to add to the compile time instead of remove it. It's going to be this method takes one argument about 2 words supply. Okay, so now I need to change the derive macro. Derive macros. Substitute bindings. Because substituting bindings now takes, instead of these two, it says it takes the context. Substitute binding context. Cast. So instead of cast cache, I have context. Instead of this, text. Cast. This is context. Cast. Yeah. It's fine. All right. Context default. This one goes here too. Substitute bindings for tuple type. What? No field definition site on the span. They are showing me fake errors again. Target is not found. Target. Yeah, because this is part of the value, I guess I also should move it here. Okay. Select target dependent branch. Implement on cast. This should go into the interpreter. CFG 2. Conflicting implementation of trait. First implementation is here. Oh, because I just copy pasted it. Yeah, I don't know. Maybe all of the substitutions should be in this module. I don't know. Depends. CTX. Substitute context. Actually, I like this pattern a lot, like combining the arguments into a single argument of a one type. You guys do that in your code? I do that relatively often, I would say. But it is like leading to the same annoyance as like the enum variants not having their own type. So like because of that annoyance, where you like need to add the name of the struct which represents the arguments, because of that you don't do that. I think you don't really. So that's why like in cast I actually make all the functions take a single argument, which is always represented like as a thing, and then that combined with like basically like anonymous structures, you can have the named arguments, or like by having a tuple with unnamed fields as an argument, you just have multiple arguments. Makes it easy to just pass all of the arguments to some other function, for example. Definition site. Definition site on castutil span. But what do you mean on span? If this is not even span. Oh, wait, hold on. This... Oh, no. Is copy. Impl-cast. Yeah, there we go. Impl-cast. This should not be there. CFG... Boom. Okay, we continue substitution of the bindings. Like it, like over here, I will use it because I can change the arguments that I have in all of these functions in a single place, instead of like going through all the places right now where they are. In most of these places, I only am going to use like 1 or 2, or just pass the argument to another function. Like this. This one is interesting here. Let's have a to do. I know what to write there. This doesn't do anything. Oh no. I think I moved everything into this crate, and now this crate is going to take long to compile. No methods for spawned. Yeah, like over here. Alright, let's instead do like a to do here. As this copy is not found. Okay, so here it is, right? If I have a place and I want to claim the value from the place, technically this only like is possible if I have the interpreter. Interpreter knows if the type is copy or not. So I think in order to claim the value, basically we need to know if it is copy, right? So I should have is copy as an argument then, right? Which will be impl fn type boolean. Is type a copy type? Should this be should be this for faster compilation time, less generics, dynamic dispatch? Sure. If is copy. This potentially can fail, so this should be resulting in a boolean. This over here, cast scopes interpreter, this, that, value, clone value, okay. So this is where I go to substitute binding context. So what is my substitution? This should not return a value at the substitution. The bindings, they correspond to places, so this should actually give me a place reference, not a value. So in this case, for example, I don't do cast scopes interpreter get. I say context substitutions for binding. If we have the substitution for binding, then we do something. Okay. Self map. A recurse cache. Wait, what was here before? Inferable for substitute bindings, for maybe not inferred. Map. This needs a recurse cache. There. Map. This is now not just a recurse cache, actually. Map. This thing should be generic now, because it should be something that has the recurse cache. Maybe not inferred. Map. And this, by the way, belongs to the inference. Oh, wait, this is inference. Shit, hold on. Ah, yeah. But yeah, the inference is its own crate. Yeah. I need this to be the full context. Right? So map. So in order to map and potentially not inferred value, we need the context which has recurse cache, which has a, and I can mutate the recurse cache, which is borrow mute basically. Or do I borrow? I feel like I want its own crate. Borrow is a different trait. So this would be mutable context. So this makes it generic over the context. Which will be the substitution context later. Or we could have the substitute. Nah, but substitution requires binding. It's already been known, which requires the types. Yeah, it's weird. Cache. Get. Get. No, not cache. That cache is CTX. This. So instead of CTX dot something, I say CTX dot cache. Recurse cache. Like this. Oh, but then it's not has. Then it's more like has recurse cache. Has recurse cache. Recurse cache then will also have a trait. Trait has recurse cache. Recurse cache mut. Like that. Okay, that works. Then find cache in the scope. So now this should be context. Like that. and then I need to implement as a recurse cache for substitute bindings context. Okay. Sure. Okay, this is the same thing. This is basically going to be match context substitution for binding. And that's it. Couldn't find path buff. Substitute bindings, cache executor spawn. Um, um, return to do. Why is the errors not in the bottom? Why do I see these stupid warnings, which I don't care about? And I need to scroll up. Annoying. Context, substitutions for binding. This over here has the cast capture. Let's replace this with to do for now. There are still errors. This over here. Or is that no method substitutions? Oh, because instead, yeah, because this is a field. Maybe I can have a method on it. Simple substitute bindings context function substitute self binding option place ref self substitutions. It just like needs to be in parentheses like this because it's a field. No more warnings, I think. Hold on. Cargo check cast types. Let's just say, because like I didn't change the other code, is this compiling? This does not. Expect reference to binding. So just do ref here. No, I do a ref here. No more errors. Now this crate takes 30 seconds to compile. Okay. This is pretty slow before I get the errors. So it's like doing the type checking, right? Okay, but I guess I can... There's this definition site, which is weird. What should be here? AST is an AST. This is span. Oh, it's because like... It's because type AST... over here is yeah, is that is AS because AST is also generic there. Fine. We do the same in the value. Compiler odd. Yeah, I don't use this. Instead say something like this. Type AST is that. Confine AST data. Struct AST data. This needs to be moved. Maybe I can move this to, let's just have a module AST here. Even if it's small. Cycle detected. As I cannot, because then this is that. Sure. I mean, I can call it cast AST here, but no. Oh wait, I can do something like this. Pub use cast AST star. AST. And library. Don't do that. Only spaghetti here. All right. Well, I mean, so this compiles in 15 seconds, right? So this is basically half of my time in this, right? So now we need to we need to split this further. Figure out where all the time actually is. All of the generics, I guess. This doesn't make the whole thing compile. This is, by the way, checking. This was checking, not building. Just check compile times. Let's do this. So this is going to like fail the compilation, but I will still see the compile times specifically of the cast types crate. Or I can like make this compile first. We'll see how fast it fails. Oh, it's not very fast, as you can see. There we go, it failed. Here's my timings. Or it's not very fast. Well, yeah. Well, I mean, first of all, like the final one. Do we see the timings after? Time total. Yeah, so like the total time for cast that failed is 2.5 seconds, right? So it failed relatively fast, I think. And before I had these errors, we had a million of errors here. Of course. Oh, that's a lot of errors. There's 100,000 lines of errors. Oops. So yeah, this is where I started this. So yeah, this over here for some reason has other things. 1.5 second. Like, I don't get what is this total for. I'm using Node to run. I have it work in both Node.js and browser. Is it possible that my computer system is the real problem? I mean, you can always improve the compilation times by having a faster computer. But I don't think I can make my... I don't think I can buy a PC that is like 10 times faster than my current one. So 34 seconds over here. 34 seconds. Monomorphization, 14 seconds. Generate, create metadata, 14 seconds. And then there will be like the type checking too, right? Somewhere, I'm assuming. Expand crate. Oh, this is a different one. Parse crate. Parse crate. Parse crate. This is... I don't get it. Why is it like there's supposed to be another line saying like compiling something else? Yeah, over here, compiling cast types. This is the one that actually matters. So there is coherence checking. There we go. Type check crate took 15 seconds. Type check, monomorphization, and the thing again, right? So now it's just like the smaller part. Okay, so I need to make the things less generic, right? That's what I need to do. Okay, let's try doing that. Let me push what I had, but I will create a new branch here, which will be called create splitting. And then we will be committing partially done code here. Okay, great. Just doesn't. All right, let's try just optimizing this crate specifically. So here's the idea then. The type is not generic. The generic things are mostly this intermediate representation. Okay, what if I don't compile the intermediate? Oh, hold on, I can probably just comment things out like this, right? I cannot, because value contains intermediate representation, but then I can just... Okay, yeah, because these things are recursive. So I cannot really do that. So yeah, this one over here is this is the generic one. But I don't know if this makes it a problem. What if I have path is test like this? What if I have a test where I basically have let's say that I have nothing here. What's going to be my error? It will say that maybe compiled function is not there. So what if I just say struct maybe compiled function? And then it says that, well, public, of course. Pub struct symbol. Pub struct expression. Pub struct binding. Scott B, hello. So far, my compilation times have not been fixed at all. But I mean, I'm trying to just do a refactor, which is very annoying. I'll just instead say that type this is unit. Noble quest. Has anyone been optimizing their code that compiles slowly and optimizing the code for faster compilation specifically? Struct whom? Derive. Debug. Copy. Clone. Partial. Ack. Ord. Hash. Implement. Display for whom? What else do you want? Is that it? Name ID. Simple foo. Function ID. I'm just trying to simplify the code here and see if this leads to faster compilation. Name. Use cargo bloat. See what produces the most. Oh, we can use cargo bloat. You're right. Yeah. Like, I know that, like, my problem is the, like, too much generic types, basically, right? Because there is monomorphization, type checking, and all of this stuff present in the timings. I can actually see what's there. Is it about the functions or the types usually? I mean, if I have the generic type, then there is the generic function, basically. Yeah. Oh my god, this is annoying. Where is it? Substitute bindings for foo. No. Symbol. Let's do symbol here. Yeah, you know what? Let's have a module for symbol. Then I remove that. And then I probably don't need ID and name at all. Binding type. Yeah, and then similarly to that, I will probably have module binding. Binding. Here. I think it's mostly hopeless activity. It will still be slow. So I just need to rewrite the code from scratch using different tactics, right? That will be like the more practical way of doing that. Just write the code from scratch. But like if I want to optimize specifically for compile times, then it's better to use the different language altogether, right? But can I have like a different language, but still have all the same guarantees that Rust gives me? So that it's both fast to compile and... We just need a better language. That does all the things. Okay, it's finished. In 0.4 seconds. Hold on. Hold on a second. Let's also check compile times just for the package cast types, so it doesn't even like go further. Just check compile times. Try cargo bloat. Yeah, I will try cargo bloat too. Or maybe it was just fast because it was incremental there. Or maybe something. Yeah, this is still slow. Even though I have removed the entire intermediate representation, basically. It is now just empty. Symbol struct foo instead. Timings. So this takes 16 seconds. I mean, 30 seconds in total. LLVM passes 3.5 seconds. CodeGen 4 seconds. Generates metadata 6 seconds. Monomorphization 6 seconds. 6 seconds for type check. Okay. So let's it's most likely not your code that causes the wait. I'm pretty sure it is. Like, I have tried compiling other programming languages. They are faster to compile. Like Gleam. Or Rock. Well, I mean, Rock is not faster to compile, but like... I mean, and Gleam is also not really faster, but they are also 10 times bigger. Cargo bloat. Cargo bloat. Let's install it. How many dependencies in the tree? Dependencies are compiled in 8 seconds. The other stuff compiles in 50 seconds. It's not the dependencies. Can I do cargo bloat package? So that, like, because the other stuff has not been changed yet. Or I can use the cargo bloat on, like, the main branch. Error, only bin, dlib, and cdlib crates are supported. Let's run this on the main branch. And this is a test. Which I'm going to remove this. And here I'm not going to remove the path. Right. Progress. Maybe. I mean, this is still going to be good if I split the crates, even if it doesn't improve the compilation times. Maybe. Maybe it still is good. Alright, git checkout main. Lake. Cargo bloat. I have async std. Don't I have Tokyo? Wait, is async std my dependency? Maybe. Figure out where it's coming from and remove. Maybe it's the time of this one. Depends on it. Maybe. Why? Oh, because it's awaiting. Yeah, because of sleeping. Yeah, should be replaced with something else. Cannot even do the bug build because rustc tries to link with fully unused external code. What do you mean you cannot do the bug build? Oh, your code. Oh, so your code is also having huge compilation time issues. How long is it to does it take to compile your stuff? Is it open source? I mean, can I try? See how long it is. Linker error in debug, release works. Are you on Windows? I think Windows. There's a thing you can do probably. It's they have the same problem in the Bevy engine. If you try to do the Bevy, it will complain. There is a thing. Learn. Quick start. Troubleshooting. Unable to debug dynamically linked Bevy application in VS Code. The program exited. No, that's a different one, right? I remember some problem with the linker. Did it fully feature flag and guard the usage of import LLVM Rust still tries linking it in debug. It's just bad compiler. You can also try a different linker, maybe. There are other linkers on Windows. You can maybe try that. Although I think the problem is not actually the linker. If I remember correctly, there might be a problem in the executable file format itself. Because there's a limit of the amount of symbols that you can link to or something like that. I don't remember the exact details though. If I can find it. Okay, anyway, look at this. This is cargo bloat. Does this look bad? I don't see anything bad here. This is the random. This is cast interpreter and cast compiler, which is pretty high up there. But like, is this bad? 0.1%? Find the full flag and output to the file. Print full function name with hash values? Or what? The full file? Per crate bloatedness? There's count. Number of lines to show, 0 to show all. Default 20. And 0. Load txt. Okay, here it is. What are we looking at? This is supposed to be sorted by the... yeah, this is sorted by the amount of bytes a certain function is taking in the binary, right? So drop in place of a vec is taking 13 bytes, right? The text section is 10 megabytes. The file size is 90 megabytes. Cast interpreter, the function that is called eval, is 0.1% of the file, or 0.9% of the text. And cast compiler full fn wide. Okay. Cast compiler expression initialize. Cast parser read one. This crate compiles immediately. I feel like this is not giving me the information. Or is it? Like, what? How am I supposed to interpret this? Using cargo bloat to optimize compile times. Guide to speeding up compile time. I am reaching a point where Rust auto recompile can take minutes depending on what is modified. Try to modularize and split it into crates. This guy already did it. And it still is slow. Not sure what to do from there. My advice is to use tools to profile executable size like cargo bloat to identify suspicious code regions. Yeah, use dynamic dispatch where static dispatch is not truly needed. How I reduced my compile times by 50% with Rust. Incremental compilation magic. It's fine, there is a link that I needed to click. Use cargo check instead of cargo build. Well, my cargo check is running for like half a minute. Hmm. I don't know, like, fast interpreter, implementation forecast, eval, closure. Size 88 kilobytes. Is this bad or not? How do I know? It could all be equally bad. Oh, look at this. Maybe that's what I should be looking for. I have a lot of B-tree balancing contexts. Like this. Some reason. Is that bad? It says 0%. There's a bunch of balancing contexts around. Is that what I should be looking for? For the things that... that are present here a lot? Repeated monoforms like that? Yeah. Can we sort by repeated monoforms? Something. Can I sort this better to understand the problem? We can sort by name. Maybe. Message format JSON, below JSON. JQ. Can I like sort or something? JQ. Load JSON. JQ. I don't know how to use it though. How big is your release executable? I am trying to have the debug executable, right? The release executable. Target debug. The cast binary is 100 megabytes. That's in debug build. For Linksider, the binary is half a gigabyte, and it's compiling faster. Just so that I don't think that's the problem. Like it literally was saying type checking. Was taking like 20 seconds. At bloat JSON JQ. JQ help. Can I like sort by name basically, right? Functions. Yeah, the functions. So like JQ dot functions. Like this, right? This is gives me the list of functions, and then I want to sort them. Sort. Out of the fields of each object. Sort. JQ, sort this. Sort by dot foo. There we go. Is there like something like... Is there something like... So I functions, and then like JQ sort by dot name. Right? Like this? Yes, that's it. Sorted bloat. Listen. And then what is this? Reference clap builder. What? Okay. Maybe like we can have a threshold for size. Can I have like where? How to use JQ? ChatGPT. With JQ, I need to get a key, filter where field is more than given number, and then sort by another key. Yeah, you have just pipes here, right? Yeah, there you go. Of course. You can do JQ like this. We have functions, And then we filter probably, right? Oh, select. Yeah, select where size is more than like 100, and then sort by name, sorted bloat. Cannot index array with string size. Wait, what? Field. By the numeric. Yeah. They have this JSON. Size doesn't matter, repetition does. Okay. There's no such thing as repetitions though there, right? In the output here. It looks like I have the problem over here. Maybe this? No, cannot index array with string size. Select. I don't understand how select works, I guess. Select Boolean expression produces an input change if the f returns true. This map dot more than equal than 2. Like they have this dot this, whatever that means. And where am I supposed to put that? Like here? I don't know what it means. Where is this supposed to go? Why does it work with sort by but not with select? I mean, maybe I need to remove this one. And index string with name. Concentrate over string cast. This makes no sense to me. Index array with string size. Like this is an array. I'm trying to select out of this array those elements where the size is more than 100. Oh. We need this parenthesis here. Never mind. This is stupid. This makes no sense. I'm too lazy to read the documentation. So without selecting, it works by just sorting. Give GPT file. This doesn't work. My copy paste is broken. I know why my copy paste is broken. Wait, can I copy something from here into here? This
Hello, Nigel Ithro.
can. What about from here to here? It doesn't. I can only copy in one direction for some reason.
Hello, Jdos Dev.
Hello, hello.
Alright, I'm too lazy to figure out why. How to use cargo bloat to identify problems. Install it. Find your biggest binary sinners. See where size is leaking from the crates. Focus only on your code. Oh, we can do filter. Filter cast. Right. When you tell ChatGPT to be annoying. Now chat, what's the biggest crate that betrayed you lately? Should we cancel regex or 31st? Is it morally correct to inline everything? Those are some questions that the ChatGPT asked you. All right. Where do I look? Cargo bloat, filter, remove unneeded dependencies, minimize generics. Okay, can I just copy paste this thing? Bloat. Bloat, bloat, bloat. Tell me how to make it compile 10 times faster. I'm instantiating a lot of closures. Heavy traits like inferable, display, and clone on recursive types. Monomorphization is being abused. You might not be using incremental builds or parallel codegen smartly.
Hello, Pigorly.
Hello, Pigorly. Turn on turbo mode in Cargo Toml. All of these things. Doesn't matter. Avoid closure overhead. Your file is a lot of closure functions. They are expensive to compile and monomorphize. Replace inner closures with named functions when they are used. They are big. Use generics. Closures costs dev hours. Closures cost CPU lifetimes. Examples in my bloat file. Cast this as display and expression as clone. Replace these with trait objects where possible. Use cargo check. Don't optimize everything. The top offender is this. Refactor eval. There is a Pigorly. JD does dev. Hello. Pigorly is everywhere. Okay, how about we do this? Since the okay. Let's do this. If
the interpreter eval is the offender. Let's remove it. How about that? That should totally fix it, right? If I just say function eval over here, like look at this thing. It returns a boxed future. It has the async move inside and like a lot of stuff. Let's just say CFG pulls, and let's have this thing, and let's have a to do inside. Does this make me compile faster? Have I considered activating Linux? Yeah, but I don't have money, and in order to have money I need to go work, and I don't have time to work because I'm waiting for my Rust to compile. So let's wait. Waiting means you have time. One big function is totally normal. Yeah, I mean, ChatGPT just lies to me. That's not the offender. Just wait faster. Type checking 20 seconds. Monomorphization 20 seconds, 22, 56 seconds total. This didn't change anything. The closure thing sounds good though. Yeah, but like which closure? Can I replace the bodies of all functions with to do? There's much inference going with closures. Can I find all the closures? Vertical bar in Rust files. Not in the Lexer, not in the AST. Probably in the cast itself over here. Compiler, built-ins. There's some wrap errors. Wait, when is it supposed to? Inner closures with name functions, when they're reused, they're big, they use generics. What do you mean they use generics? You cannot make a generic closure. Your non-incremental build takes 30 seconds. Dependencies taking most of your time. Yeah, that's not the case for me. For me, the dependencies take 8 seconds. And the crate itself takes 50 seconds. I'm just writing code differently, see? I'm writing bad code. That's resulting in bad compile times somehow. Yeah, because I have been writing code without thinking about compile times. So we need to now rewrite everything from scratch while thinking about compile times, right? Like, why can I not have a better... like, tool that tells me what exactly do I need? Like, I want to use a lot of things. What things? What things? Uh, mhm. And like, I mean, the eval was not even there. Like in this other branch that I just started, right? In this branch that I just started. Um, I have a crit that doesn't even have the implementation. So this code that I'm trying to compile, just the cast types. This is just having the definition of the types, right? And it still compiles for like 20 seconds, like this crate, not the dependencies. Why is this like crossed out until I click on it? Like, look at this. Cargo. Clean. Cargo. Build. Package. Cast types. Timings. Here's all of my dependencies. See how quickly they go? I only have 100 crates in total. That's like nothing in Rust. And here you go. Now I'm doing the cast types itself. And this is going to take 50 seconds. Here's the timings. All of my dependencies were compiled over here in the first 8 seconds. And then the types, okay, this is like extracted part of cast, which is just like having some of it. And this has 30 seconds. That's not normal. Yeah, so like how do I figure out what is wrong, right? There is like some generics, something. Like what is it? What is it? Can I like selectively delete? For example, let's delete the substitute bindings completely, right? Let's delete this. Substitute bindings, delete it. Lib, delete, delete. Implement substitute bindings. Let's just say substitute. Down. Just types. Remove. Like maybe this for some reason, the implementation of this trait for everything. Just as a test. And in the drive macro, I will just remove this too. Imagine if no version control. Well, you just copy paste the folder. That's how they did the version control back in the days, I guess. Control C, Control V. This was still slow. So this is the new one. So I only recompiled these things, and this still takes 30 seconds. Right. So this didn't change anything. Okay. I'm going to undo. But what if instead, like how am I supposed to guess? What's the problem? I'm not supposed to guess. Like, how big is this code even? This is 4,000 lines. It takes 30 seconds to compile 4,000 lines. Which is like 7 seconds for each 1,000. That's like a lot, right? Where is it? Let's try removing some things. Let me try removing this thing completely. I mean, I already tried that, right? That. So maybe compiled functions are now not there. I need to just remove that, I guess. Expression is not there anymore. So I need to remove that. Maybe that's enough. Expect template can no longer work. Expect function. Template. Condition target dependent branch has condition, which needs to be deleted because we don't have the expressions anymore. Oh no. Imagine LLVM compile times if it was written in Rust. It depends how you write your code. I just need to like understand what am I doing wrong, right? Like again, I tried compiling other programming languages. It compiles a lot faster. I'm just doing something wrong. I need to find it. I remove the template from here. Fine, I'll just remove this altogether. Maybe it's try hash. Maybe. Why would it be try hash though? And how do I confirm that it is try hash? I can just, so I guess I just remove the implementation of the try hash. See? Okay, this was actually big. This was actually big. I think. Let's check compile times. I just removed an enum, which is the expression, the intermediate representation. I mean, there are multiple enums there, not just one. It's still slow though. Maybe that actually is still slow. Hold on. Because I was doing cargo check, right? Not build. And check worked in 6 seconds. "15 seconds total for the cast types. 50 seconds total for the whole thing. Monomorphization 5 seconds. 5 seconds for the check, for the type checking. Okay. So it's 5, 5, 5. Yeah, it looks like this is, maybe this is just like linear. Let's, okay, let's just try minimizing this even further. What if I don't have, what if I only leave the types here? And get rid of the values, right? Let's actually make a new branch. Git checkout. Deleting code. All right. Deleted this. Let's remove value altogether. Target symbol. Substitute binding. Yeah, that's fine, maybe. Let's do one thing at a time. Value. Target. I'll remove that. That's a small one. place to do. Expect error. Oh, expect error is not found because it was in the thing. Hello? Value. Expect error. This in library. Oh, expect error. Yeah, not have the default. Look up in the scopes. We're just going to remove this method. Insert, we're just going to remove this. Insert. 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 Take. Result. To do. Get mut. To do. Get. Whatever, remove. Remove all of these. And that. Place state. Place state cannot be occupied anymore. Substitutions. Yeah, they give me the place references. To do. To do. Yeah, there is no values. No temporaries. Into value. Remove. New temporary. New. Remove. Make same. Into value, into value. To do. Value. Await fully inferred. To do. Okay, whatever. Target. Enable cast. Name part. I'm just going to remove that. Instantiation also. Okay. Context get runtime is not there. Search runtime be possible. Runtime context. Hash map key. That. Okay, 1.4 seconds. That's how you improve the Rust compile time. You just delete all your code. Just wait until you delete everything, then it's going to compile in 0. Right? Cargo. Cargo clean cast types. Cargo build. This. 3.4 seconds now. Okay, but I mean, for such a small crate, now that I have deleted it, right? Like the fact that this takes 3 seconds right now. How much code did I leave? I left 2,000 lines of code, which still means like 1.5 seconds for each 1,000 lines. The code actually just 1.5. The next great cast feature, there is no cast. Yeah. Alright, let me do the push-ups real quick. Hold on. Wait, did I do only 20? I thought I did like 30 push-ups today. Like, I feel like I still need to investigate why this crate takes 2 seconds to compile, right? Isn't that still too much? For 2,000 lines of code? Let's remove more code. Substitute bindings, remove. Okay. So we had 3.06 seconds. Now it is 2.93. So this was 100 milliseconds removed. Is this still or is this like an error? Let's try doing this multiple times to see how much the time changes. 2.94 this time. I think this should be like pretty stable timings. 2.95 this time. What caused the big jump? Me removing code. I like, maybe it's just proportional to the amount of code. But I mean I have like the same derives still, like the same like the same things for all of my types, right? I just get rid of some of the types. You know. Yeah, this is pretty stable. Okay. It's increasing. No, it went back. 995. So yeah, it's it didn't even remove the 100 milliseconds, like 50 milliseconds at most. That thing. Let's remove more. Let's remove scopes. I removed scopes. That was 600 milliseconds. That actually was maybe big. Why is scopes that big? Scopes? Weird. Let's see what's there though. What is here? We have some scopes. We have some scopes, so like some structs that have some methods. Is this highly generic? No. This is having absolutely no generics in itself. It says hash maps inside. Maybe like it's instantiating these things or something. Locals. Okay. Let's continue further. Like, it still is slow. It is still slow. A language without scopes, without eval, without even values. Get updated website. Let's remove AST. Removed AST. That didn't do anything. That makes sense. Let's remove binding. This means that the binding type should be removed. Two point 2021. Next, remove the symbol. My Git just like it doesn't watch it anymore. .1 second. Okay, still 2 seconds. I feel like 2 seconds like is still slow for this. There's literally nothing. I remove the name now. Symbol gained like 2.2 seconds. Maybe I should have committed like how much we gained. Also, this is rounded. Maybe we should probably look more like at some number that is less rounded. Like this type over here, right? This has 2 dots. This now 173. What else can I remove? Place. Let's remove places. I'm back. Did you find it? No, I'm just removing code now. I'm addicted to removing code. I'm not going to stop until I remove everything. .7 seconds. So I basically got down to 800 lines of code, which are compiled in 1.7 seconds, which I feel is still slow. Like, debug build should not be building that slow. For 1,000 lines in like 2 seconds, that's a lot. Right? Switch to crane lift. I'm not even doing any code gen here. This is a library. This is creating the Rust lib. And it's not the code gen. It's the type checking according to the timings that I had before. Context, remove. So we just have the types now. And context, yeah, functions now don't have contexts. .166. Wait a second. This halved the time right now. The context. Hold on. What did I remove? I removed the context, right? Which is just so basically this is like the algebraic effects stuff, kind of, right? So we have the functions which know their contexts, which is like a hidden argument kind of thing. I feel like this is just an extra field, and this is just like awaiting one more thing. So I think the problem is in this file, in the context rs, probably. Like, what if I don't delete this file, but I still remove all the fields, you know? What if I do this, but I still remove all the fields? It derives, hold on. 1.27. 123. I don't think it's derives. Do I even have derives? So this is just remove only usage of contexts. Contexts. This is the thing. Let's stop the Rust analyzer. So what do I have here? We have contexts. This is the struct. It has a maybe not inferred context data. Oh, wait a second. Maybe because like over here, I'm basically instantiating this generic. And that's what's taking time. Let me try to remove all the methods from it and just have this thing. Like that. I can even remove the derives. I mean, yeah, let's do just that for now. It must be inferable though. Inferable for context data and for this. Yeah. Which means that I cannot really remove this code. I cannot remove this code because this is the type. Which does that. I mean, obviously I can remove this here, for example, but I don't think this will change much. Or state t, data t, arc t, check t. I can try doing that. What? Oh, because I derived the debug. Did it? Let's remove this thing. Now it doesn't implement debug. Implement std fmt debug for maybe not inferred t. Function t. Still the same. And now I try to remove this. Required by partial. Yeah, fine. I remove all of these derives. Okay. We found the code. Kind of. This is it. Maybe I will like check this commit again. Let's just remove it and see. Like I have the same derives maybe. So maybe like some of these traits, maybe like try hash, like you said, is having a lot. Yeah, this doesn't change anything, right? Type. Okay. Let's remove the try hash here. Try hash is the problem. I wonder who wrote it. I don't think it's the problem, but we can try. See if it is. Like we had 0.84. Now we have 0.84, right? It's literally the same. I removed the try hash. It's not the problem. Let's move everything into the single file so that it's easier to see. We have a single file like this. Are they removing most of the code? I mean, it still is slow, right? This is 400 lines of code. This is supposed to like compile instantly. Almost. Not take a second, right? All right. So all I have is the type shape, which is this enum. Let's try removing the things from it. For example, let's remove the implementation of the inferable for it. Let's make it not inferable anymore. Let's not have inference. Because this is the like async trait and stuff. I feel like maybe that's the bad one. There's a bunch of inferable things. Bunch of async traits. That's probably it. If I was to guess. Just remove this. Ors needs the things. I can have an in the inference though. Maybe not inferred. So it's the inference. Compilation with a single empty function to know the base point. True. Board for yeah, let's just do this here. To do see display. Also don't require inferable here. Oh, what if it's this one? $0.35 from 0.9 from 85 to 0.2 actually just 0.2. Okay, so it's basically instantiating some of this code. Okay. All right. Let's try undo this change. And instead so in order for this to compile, I will just say implement inferable for type shape. Okay, and we just have a to do here. See what's the difference. This is 0.4. Okay. How much is it if it's all empty? Fine. Let's just remove this. Empty one takes 30 milliseconds. Empty file. 30 milliseconds. Okay. Now the question is, if my type shape, what if I make the, what if I remove the things? It's just like, let's remove some of this, like that, you know? Let's remove like this bunch at first. And see if changing why did I remove some in the middle? Let's just remove in the beginning until string. So this is 0.33. And before that, it was 0.30. Okay, so this is the same, right? Even so, I'm just thinking, if my enum is empty, am I going to still have the problem? Wait, what? Didn't I pop? Reload. It wasn't just reloading anything at this point, I guess. Okay, let's remove like half of this. Actually start Rust Analyzer. It's starting automatically. Nice. Maybe we'll check. Hello? Cannot find issue that causes 50-second compile time while being at 0.3 seconds. You think not? Like, maybe just like linear. Like, for example, I just want to test a theory here. If I remove all of the enum variants here, what's going to happen? Is it still 33? Because it might be still. Okay. Stop Rust Analyzer. Zero 28. This barely removed any time. Right? Okay. Okay. Let's try even more. Let's make this type empty. Let's just go all in. It's empty. Go back and try remove specific features trait. Why can I not do the same here? Like, you see it still is the same time with empty type. So it's the Terrate implementations or something, right? So I'm down to 100 lines of code, which compile in 30 milliseconds. Expect error, cast. Still the same. Okay. It's inferable, right? I think. Let's remove all of the extra type, so there is only the type shape is the only type that I have. These were used as inner types before. So I just implement 3 traits here. And this is, okay. This is now better. What did I remove? Wait, maybe I removed too much. This is the type shape still. Tuple type. Okay, tuple type. What did I have? So this is some derives here, just implementation of the display. Let's just remove it anyway. This and hash map type too. Can I have like can I have more precise timing here? I think I can. Check compile times. I'm just going to clean the cast types and then do that. Okay. Finished in 0.48. 100 milliseconds. LVM passes. Code gen. Monomorphization is collector craft walk. And then the type checking. Like, it still is proportionally the same, I think. There's coherence checking, though, now that I think was not there before. So here, 5 seconds, for example, right? There, yeah, coherence checking is like something that is now interfering, probably. Like, it's not that easy to just remove some types on the back full 50 seconds code. But this is maybe like not telling me much anymore. Indeed. $103. 77. Okay, hold on. So basically, you're saying that by just implementing the standard format display, I add like 30 milliseconds, 20, 30 milliseconds. Show sure doesn't do that. That's another trait. The implementation is kind of the same. Just has different types. But this one does not remove any time from compilation. Wait. It's maybe like a little bit... No, exactly 100. Okay. Move the debug. Removing the debug. I was going like about 90 maybe. Display. It's kind of the same. Yeah, I don't know. This is too small number now, yeah. For sure. All right. Okay. Interesting. Using things actually makes it slower a little bit. All right, and there we go, the empty file. I need to go back to the thing, which was like, this is it. This one. Do, 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 do. So this is when the code was compiling for 083, right? This is when we halved it, right? So if I do git checkout add like this, and then I do that, then we go to basically like twice as much. 121 versus like 08, right? $0.85. And what happened? Maybe not inferred. Oh, it was the context. The contexts were deleted. Right. Okay, so we have 1.23. We have contexts. What if I have context still, but I remove all of the methods from it? Okay, that's as the things. Okay. Maybe this one. So this one is taking a generic argument, impl iterator. We have some closure inside. Essentially. I feel like this function deletes a lot. And this one didn't delete anything. This one with impl iterator, right? Maybe it did. At the same time. Why is it exactly the same time now? Okay, single move. Let's try removing this partially. Down, down. If I don't do the extra spawn. If I do a to do here. That increases the time because I don't know. I'm getting nowhere. I mean, one of the things that I could do, I guess. So, like, for example, like I understand in theory that, let's say that I have this, right? I have this function spawn, which takes an impl future, right? And then we have some big code inside. Like, this is relatively big, right? So instead of this, I can have something like this, you know? Let me just undo everything. And I'm going to check out create splitting, I guess. So I go to the executor and I say over here. So yeah, let's just see the types again. The time. This is before I deleted everything. This is 50. This is like 20 seconds, not 50, 20, because I removed. I extracted the cast types crate here only. This is not like the biggest function though that's being used. Maybe like I should look at the inference. But like basically the idea as far as I understand, like this is being duplicated, right? When I spawn a different future, because it's a generic argument. So instead we have a very simple function, which is like basically the implementation of this. It's maybe even better to do this inside and having like this being like self. I cannot use, can I use self here? And instead of this I will use this, right? Okay, and then spawn impl self f. No? Self is not executor. Like if I do it like this, this is not going to change anything, by the way. Because this is still like generic over here. We need to remove the generics. So there is only one instantiation basically. And then the one that is generic is going to be like a thin wrapper around the non-generic one. So this one is going to take actually a boxed in future. Like this. So then I spawn the boxed. This one. Right, so this one takes 31.6 seconds. Result T. Spawned T. Oh, this is still generic. Yeah, okay. I mean, there are two generics here, the impl future and the T itself. So I guess in this case it should still be T, but not like, but this should not be generic anymore. Like, because this one has to be generic, yeah. And this would be... How many different things can be spawned? It's like a task. It's spawning a future, returning T. It's like spawning a thread. Oh, it should be a pin box feature, right? Pin box, of course. That's why we couldn't wait it. STD pin. So now T must still be send sync static. This still needs to hold. It's just like it's removing this generic only. And then I do box pin. But this is probably not going to be felt because I'm not spawning really a lot of things. Right? Like I'm spawning the thing here to compile a function. I'm spawning a thing here to instantiate a template. And I'm spawning a thing here to type check the contexts. I'm spawning a thing here to substitute the bindings of a compiled function. And that's it. So this is like not going to change much, but the same idea, like you can see this being used in the standard library actually, right? I don't know. Is there docs std? Like for example, let's actually look at the thread spawn because it's the same function, right? And you look. So this one is generic, right? fn1s and shit. Source. Function spawn unchecked. No, this one is still generics. Spawn unchecked underscore. Which is still generic. I'm pretty sure I saw this somewhere. But I don't remember where. But let me take a look at the inference, for example. Like this, display implementation for I don't know. I don't know where would I do that. I don't know. I don't know. Are we going to just surrender to the Rust compiler? What else can I try? I remove specific features, traits. Non-async rewrite. Yeah, like maybe this is because of the async, right? Because the code that I compare to is not async. So if the async code takes like 10 times longer to compile, like I need more case studies though. Like, is async code more like longer to compile? If I have same code in Rust. One is async and other is sync. Which one will be faster to compile? And how much? Sync Rust will almost always compile faster. That makes sense. More memorization, heavier trait resolution, and more generated code. How much? Like from 1.5 to 4 times. Example. I think it's a spawn used with closure. Side another. Async is not in concurrency. If I rewrite without async, let me think about this. Then I need to basically implement async with sync code, which is like having callbacks instead, or doing like some other like polling, like if it's either callback based or poll based. That's going to take a long time to rewrite. So async used for currently for waiting for things to finish. Like for example, when I compile code which needs a like let's say that I have mutually recursive functions, right? The function f is calling function g calling function f. So I need to like compile the body of function f, and I need to know what g is, right? So I need to wait for it to be available, kind of. Basically, when I see like an identifier in code, I'm trying to wait until that identifier is known, because the compiler might need to do some more work for that identifier to actually appear. This could be solved like differently with having passes, specifically for like identifier resolution. Another example is what? Like so like when you define a function in general, right? The type checking for the so I'm trying to compile the function and type check it, right? But you don't need to do this immediately. You need to do it somewhere like in the background, I guess. Okay, so the alternative would be could be to use threads, but then I cannot compile to the web easily, to the WebAssembly. So like I compile the function in the background, but when I call the function, it must already be compiled. So I'm waiting for it to be compiled, right? Sometimes I wait for the types to be fully inferred, or not even fully, like partially inferred, because like when I'm compiling a thing like object.field, I don't know what the type of object is, right? But in order to know what's the type of object.field, I need to know what the type of object is. So I'm waiting for that type to be compiled, and then like setting the type, right? So that could be done with like callbacks, for example. Like once the object type has been inferred, we can like advance the type inference. You have 5 stages. Yeah, I don't have stages. Populates simple tables, does imports, checks type definitions, const evaluation with dependency trees are resolved, per function type check. Yeah, like I can like I should be able to potentially evaluate code that is not fully type checked I should be able to evaluate code which is not yet like think about this. We have a macro system, right? So I want to be able to write a macro and then invoke it, right? Invoking macro means generating code, generating more AST, which means that let me just find an example with a macro like this over here, right? So I call a macro hello. This generates this code. This is a function. This is a function that needs to be compiled. This is just a normal function. It just treats ASTs as values, right? But this just needs to be compiled while I am basically parsing, right? So I don't have stages like that because I need to invoke it while parsing. Like Rust has this in stages because Rust says that you must have your procedural macros to be in a separate crate. I don't need that. Usually macros are expanded on syntax parsing. Yes, that's when I'm doing it, right? And because macros are expanded on syntax parsing, and macros are defined in the same syntax that I'm parsing, I need to do them without stages. Sync compilation is basically same as like another word for it would be lazy compilation, I guess. Oh, it's not like exactly lazy, but like yeah, it's kind of similar to being lazy. Like awaiting something means that I want it to be done right now, right? But I'm basically waiting for it. With lazy, you just say instead of await, you say like I need this now, and then this can trigger some other like code to be triggered. Yeah, I don't think I want to move to passes because that like just breaks the language completely. You cannot do that. Like I cannot have a separate type checking phase because type checking potentially needs to also invoke code. So like that's why I'm saying compiler is the interpreter for me. I need to be able to run code that is not yet like fully parsed, type checked, or whatever. I mean, okay, like I could move back to another language if we see what's the fastest like languages to compile. Do I want to switch the language though? So I think it should be either OCaml or TypeScript. Then both of them will be annoying. What else? What other are the options? I mean, if OCaml, maybe like maybe Gleam actually. Maybe Gleam. If I consider OCaml, I should consider Gleam probably. Keep forging on, then switch to cast ASAP. What about Haskell? Haskell, I think, is even slower to compile than Rust. Gleam is for web dev. It's a general purpose language, I'm pretty sure. Maybe we switch to Zig. How painful will it be to actually write that shit in Zig? I'm wondering. Haskell or Rust? Which one is fast? Hold on. Which one is faster to compile? I'll be re-implementing async either way. Yes. That's the wrong question. The real question is how entertaining that will be. I can see that it can be... I can see how it can be entertaining in the beginning. But like once... like we figure out how much how much pain it is, like after some time it can stop being. Haskell generally faster, especially for small to medium projects. Wait, what? It was... Would you rather wait for a fast program to compile slowly or to compile a slow program fast? Yes, that is a threat. Does OCaml outperform Haskell in runtime? I don't know. I don't care about runtime too much. Because once again, like runtime, like I just transpile to JavaScript and then we care about that. We care about how good of a code I generate, or I compile to native code and that, or with JIT and stuff. Yeah, Rust is a good language. Like I don't want to get rid of it, but the problem is that I don't know, I feel like waiting for a minute is too slow. Rewriting from scratch, I was thinking about that anyway. Just to... but I was thinking about rewriting it in Rust from scratch, like without changing the language. If you want small compile times, maybe you should try underscore underscore. What is this? What is underscore underscore? What's the best? Oh, Go. What's the best language to use to implement my own language? It's difficult. It's hard. Rust is best for compilers. A lot of languages are... a lot of people use OCaml to implement. Classic masochism, C. You like pain and segmentation fold? Be my guest. Go. Don't, but you can. Will have, it will work. It won't be fun. All right. I mean, I tried crane lift, at least for dev. But how will it change? Like, what do you mean crane lift for dev? Like, to compile my code? I don't even get to the code generation. Code generation is the smallest, time. It doesn't matter. Let's go back to main. Like, code generation is not the problem. If I switch to crane lift, it's not going to... like, because it's not even getting to LLVM. It's not the LLVM that is slow. Haskell. You would have to do a lot of things in ways you don't want because of absence of mutations. Yeah, but that's also a good thing, I think. Use an alternative backend to build Rust project. I don't think I think I was using Mold as a linker, but like once again, it's not the linker. It's not the linking time, not code gen. That's slow. I mean, it could be faster, but it's like 3 seconds out of 50 seconds. No. I think not right now. Like, here's my code, right? It's compiling for 50 seconds. And this over here, this in the end, is the code gen. Code gen is 4 seconds. Well, I mean, 4 seconds of code gen, like if I wanted to optimize this 4 seconds to be like less than 1 second, I could have the mold linker and crane lift, I guess. Maybe that would improve the code gen, right? But there still will be these 50 seconds. F sharp. I never written F sharp. Is it fast to compile though? Is F sharp fast to compile? Faster than Haskell and Rust usually. But I'm not writing usual code, right? Usually Rust code is faster than what I'm writing. To compile. C sharp. Are you sure Haskell is faster to compile than Rust? GHC gets real slow with heavy type level magic. A lot of type gymnastics and GHCs. Like, I feel like the way I write code, I will have a lot of type gymnastics and stuff. What's a good project to try? What's an example of a programming language written in Haskell? Idris, Elm. Like, let's try something simple like an Elm or a pure script, right? Like, I want to try to compile it and see how fast it is. Compile it. Right, I tried compiling Gleam, which is written in Rust. Quick links. Compiler source. Cabal. CD. Clone. Install. No? Should I just do like Cabal build or something? I don't remember how Haskell works. I just installed Cabal. Elm is abundant, is it? Is Elm abundant? Nope. PHC. Search. Haskell. Cabal. Cabal install, actually. Well, because this doesn't install it, right? Well, install. Well, build. Right, let's see. Trying to regenerate the index cache. We are downloading dependencies. I'm building. Oh wait, it's building and downloading at the same time. Isn't that cheating? Let's see. So like a rock language, for example, in Rust, compiled in 2.5 minutes for me. The Gleam compiled in 1 minute. The project's compile time is 27 seconds from scratch. Yeah. Could improve the drastically by creating many crates instead of one big cast crate. Yeah, but it's not easy. That's what I was trying to do today. I still didn't do it. I kind of did, but not exactly. Like basically your PC is like twice as fast as mine. It still is slow. It's only like what 20,000 lines of code for me, right? It's just it's less than 20,000. It's 16, 17,000 lines of Rust. Not a lot. Fail to build zlib. Right. Feel like it's not that easy to do that. Vim. Do this instead. GHC. Global install. Zlib. Nope. This new style. Why is this new style not ignored here? Like, how are you supposed to compile it usually? Travis. Docker build. T-elm installers Linux Docker file. Oh wait, I can just try to do this in Docker, right? Deploy. Wait, where's the actual... There's GitHub. Maybe they don't use the Travis anymore. Workflows. Comment on pull. When pull request is opened. Issue expectations. Where's the actual CI? Like Travis, I'm assuming, right? Docker build. Installer's Docker file. Docker copy. Create Elm. To here. Yeah, I guess the Docker file includes. Okay. Installers, Linux Docker file, right? Yeah. This is my dependencies basically. It's fine. I'll try to do it like this. Ignore this new style. X strength. Oh, I'm just interested. Cabal build. I thought Haskell is like slower. Maybe like Haskell would be even better than Rust technically because like of the more advanced type system. But if it's compiling slower, isn't it going to end up being even worse? Hello, Badcop. Cabal, you're writing in Haskell. I'm just if Haskell compile time is not too bad, then I think rewriting in Haskell, I wouldn't mind it too much. Even although I hate some parts of Haskell, but I think I can get over it. Would it be Rust called if it's compiled fast? Just fast? Fast, I think. Language detection tool. Or we do Zig just for content. How annoying is it to write Zig if I like Haskell? Writing Zig if you like Haskell is like trying to tango with a grumpy crocodile while humming a Gregorian chant. Our two forms are different planets. Zig does have a pretty nice compile time, simple syntax and memory control. What if we make a new language without these problems? Yeah, but like, how to get there? How to get there where we like making a language that does have this problem is a big project. Like the Elm is still compiling, by the way. This is Haskell. Is this like this reminds me of CMake and C++. This is compiling this one file here, the reporting error syntax, and it was compiling it for like 10 seconds. Just the syntax of the errors. This looks like it's not faster than Rust to compile. Isn't it just a problem if you use a lot of crates? Same with Haskell. I'm not compiling the dependencies right now. I'm compiling the code. Like, I don't care about the dependencies being slow. And even then, like, once again, my code, profiling the compile times, it says that the dependencies, here's my build times, all right? Here's my build times. This is basically from scratch. The first 8 seconds, we compile the dependencies. The next, this is part of the thing. Yeah, the first 8 seconds is the dependencies. The next 50 seconds is just my stuff. And then the Haskell didn't even compile. Exception in when trying to run compile time code. Wait, you can run compile time code in Haskell? GHC. Are you somewhere with a slow internet connection or no internet? Oh, it was trying to like verify the stuff. Okay, it basically compiled everything. How long did it take? There is no timings. Can I clean after myself? How do I clean? Dist new style. Maybe I just remove dist new style like this and time cabal build. Like it already has downloaded the dependencies, right? So this is just going to be compiling. Yeah, and see, this is already compiling. This is already compiling my like the Elm code itself. So it's like it's already done with the dependencies, right? Is it in the output that Elm make is faster? Where? What am I compiling? I'm compiling the Elm programming language. You know that? Not Gleam. Gleam has already been compiled. Elm language. Delightful language for reliable web applications. It's like a simpler Haskell. Oh, what about PureScript? PureScript. Hold on. Because I heard good things about PureScript. If we think about Haskell, is PureScript like, is there a thing in PureScript that does it that is not there in Haskell? Is PureScript faster to compile than Haskell? Nope. PureScript usually compiles faster than Haskell. What do you mean? This is a yes. It's a smaller, simpler, and targets JavaScript, so it skips all the heavy GHC wizardry and optimizations. Which maybe is fine for me. What if I just compile to JavaScript? Haskell's GHC is a beast with optimizations and type checks. Well, PureScript also has the type checks, right? Isn't the type system? What features are there in Haskell that are not present in PureScript? Or maybe I'm thinking of a different language. Haskell is lazy. PureScript is strict. Rankin types, data kinds, dependent type-ish with GHC type families. Don't they have that? I thought they have it. Higher ranked poly. Oh, hold on. PureScript, higher ranked polymorphism. PureScript. About to readable JavaScript. Or use existing JavaScript easily. So we can basically like we can combine TypeScript and like and PureScript at the same time, because TypeScript is the fastest one to compile for sure, right? If we hit any problems, then we go JavaScript. How much time did Gleam take to compile? 1 minute. It's just my code is bad, you know? Algebraic data types, pattern meshing, raw polymorphism, and extensible records, higher-kinded types, type class with functional dependencies, high-rank polymorphism, right? Like, it's good. I think it's good. What's the problems with this? Anyone uses this? mvar stm, I don't think I care. Low-level system access, I don't think I care. I can do JavaScript. Template Haskell, I don't know. Never used that. I don't know if I like, maybe I will want to generate code. Though I use the derive macros and Rust a lot, right? Let's write cast in every language and finish in 2065. If it takes like 1 hour to compile, like after I add even more features, like every feature I add adds like 1 second. Like every day I work on cast, I add 1 second to compilation time basically. So like, so like in a year it will be compiled in 5 minutes. No, not 5 minutes, like 10 minutes. The new TypeScript compiler is crazy. You mean like crazy fast? Maybe I just do TypeScript. I just try to be really careful, like use it like some sort in a functional way. (10x) faster. So yeah, they have like 1 billion lines of code and they compile it in 7 seconds. What's native? Native implementation. What do you mean by native? Does it compile to native code? Native port of the TypeScript compiler and tools. The native implementation will drastically improve. Oh, you mean like, I mean, you mean the TypeScript compiler itself was written in JavaScript, right? And now it's written in like, as a native thing. Okay. The TypeScript compiler itself is not native, yeah. Okay, sure. Yeah, I remember them choosing Go instead of Rust because it's easier to rewrite the existing code or something, right? That was them. Okay, yeah, so this took 80 seconds, which is 1.5 minutes to compile. It basically compiled everything, right? It basically compiled everything. And we have wait, where's the Haskell code? Oh, Haskell, there we go. We have 50,000 lines of Haskell code, 35,000 lines. Actually, the amount of lines of code is not that far from my current code base, right? It's just twice as big. And it compiles 1.5 times slower. So, like, basically the same speed of compilation then. Is it? I don't know. I'm still like thinking about this one then, because it has a good type system. Still, it's already like JavaScript, and so we can also switch to JavaScript if we want. $1.5 million, not billion. Yeah, I know. Euroscript seems terrible. What does that example even do? Let's take a look. I didn't read the example. You don't like Euroscript? Do you like Haskell though? This prints hello world. Greet is a function that takes a string, returns a string. So you say world and it prints hello world. You give your name and it greets you, right? Our name is world, so it greets the world, and then it like prints it. No, this is good. This looks nice. If you like, it might be a little of a weird syntax if you never worked with a functional programming language, I guess. Try compiling Rust. OCaml source code. I did hear that OCaml is like basically very fast to compile, but like, I don't know. I already tried OCaml, right? And then I quitted to Rust. It was a little annoying, but I don't remember the details now. We can go back to OCaml, figure out why it's annoying again, and then go back to Rust. Why not Golang? Yeah, why not assembly or C? Do I just clone the Rust? Wait, how long does it take to compile the Rust, you think? How long does it take to clone the Rust, you think? New cool language when, like Odin or something? There's something better. What's a language with a good type system and fast compiles? Rust? You want something lighter and super fast? Then OCaml. Compiles way faster than Haskell's GHC. Can we try COBOL? I never even looked at it. Is there a website for it? COBOL tutorial. Is COBOL still relevant? It's still extensively used. Give me a line of code of COBOL. Hello? Overview. Stop run. This language says stop run. But I don't want to stop run. I want it to run and never stop. Oh, camel, my camel. Okay, this is the OCaml stuff. Makefile.in. This is a compiler and suite of associated libraries for the Rust. There's a makefile. A bunch of MKs. Wait, didn't they like use Dune in? If this is OCaml, should they be using Dune or something? No, this is already Rust. Oh no, this is standard library probably, right? Maybe this is just standard library. I don't know. Not enough instructions. Source boot. There is no instructions how to build it here. Entry point is source boot driver main. Yeah, here's some ML stuff. Why is there a folder called BE? What's BE even? ABI, ASM, ELF, EL, Mako, PE. So this is the target, right? Different targets, right? Or something. x86, MAC, PE. FE. AST. Item, Lexer, Parser, Token. ME. Alias, Dead Dwarf. Layout, Loop, Resolve. BE is front end, backend, FE is front end, ME is middle end. Weird. Sure. Hello, Ball City. What's up? We're thinking of leaving Rust, rage quitting Rust because of the compile times. Just wiki Rust environment is incrementally recompiles in 1 second on my 4-year-old desktop. It has 3 ends. It's a triangle. The back end, the front end, and the middle end. No. Let's rewrite from scratch. Because why not? Pure script. Tell me more about pure script. What are your thoughts on pure script? Ask someone in the Haskell. Why a Haskeller should learn pure script. The main reason is pure script is primarily compression packages JavaScript, and there are some battle-tested production-ready browser front-end libraries written in pure script. Using these, if you already know Haskell, is a breeze because their languages are very similar. There are also some Haskell libraries that compile to JavaScript through GHC.js, but with that YAMV, my knowledge is like battle tested. Yeah, sure. Like, I mean, our target is not really to compile to JavaScript, but PureScript fixes Haskell. Well, see, PureScript is literally the better Haskell. It fixes the records, which is why I rage quit Haskell, literally. So, like, that's why we go there. We have a largest 160,000 line of code frontend in PureScript that talks to our Haskell backend. Because of their similarities, we can have very similar coding styles, which is nice. There is also no huge awful context switch. PureScript, I'm wondering, so like they have 160,000 lines of code. How quickly does it compile? PureScript is certainly not without its warts, though. Many of the otherwise best libraries lack documentation. There's no equivalent of a Weeder. There's an annoying, outstanding issue with it treating warnings as errors. 1 year ago. Warnings as errors. We have our own front-end Elm-like framework. Stuff. Rewrite cast in Clojure. If I wish to learn a new programming language, which one would you recommend? Kindly do Clojure. I don't know. Which languages do you already know? Should we do Clojure? Is Clojure a good language? No, it's not, right? It's a Lisp, dynamic typed. Clojure is a Lisp and it's dynamic typed. I will not do a dynamically typed language. No. That's the worst. I'd rather wait for my Rust to compile for a minute. A Lisp, I don't mind a Lisp. Is there like a typed Lisp? Is there any next-gen strict type Lisp offspring? There's Coelton if you want an ML language like Haskell. See this intro. Coelton is a statically typed functional programming language built with Common Lisp. Computing Fibonacci numbers by exponentiating functions, not numbers. Sure. This is the fully native x86 assembly for the hello. Isn't Common Lisp supposed to be dynamic? What can we do? Type system. Isn't as advanced as the GHC, but we do have parametric polymorphism, truly parametric algebraic data types, type classes, alright, are kind of types, okay. Could try Zig and rage quit it. I mean, I already tried Zig, right? I didn't like write a big program in it though. I drew a triangle with OpenGL though. Monads, just kidding. Wait, what? Actually, we're not kidding. Monads are implemented. Nice. Yeah, so like, sure. But like, I don't think I should try to use a language which is barely used by anyone. They have 1,000 stars. Is that a lot? Compiler rewrite club. Like OCaml just has 6,000 stars. This one has 1,000. It's not too bad. How much is Rust? 100,000. Do I rewrite in the same repo? Well, I start a new branch from scratch, right? I already had the, like I did with Rust. We have 500 commits in the Rust. And the older Camel version, 165. This literally happened, by the way, exactly like 1 year ago. We do a new rewrite every year. How about that? And then eventually, after a certain amount of years, we rewrite the language in itself when it's ready. Might as well use Kotlin then. I don't think Kotlin is a nice language. I don't like Kotlin. I tried it already before. Is there? What do I want? Not Elm. Like, I just want to know more about the differences between the pure script. How fast is pure script compilation? I need numbers. Haskell versus pure script. The difference is complexity. They're too popular. They say that they're both popular. Do you guys know that Haskell is popular? And pure script also is popular? Not possible to read it. High-level overview. Compiler times are a lot slower than Bagel script, but a lot faster than GHC. Is it better than TypeScript or Elm? If you come from FE, Front end. Does it also matter how fast cast is at the end? I don't know. I don't think so. Because I write a language, right? Eventually, we have the native backend, which should be quick enough. I mean, that depends on how good do I write code. How well of a code do I write myself when I rewrite the language in itself, I guess. But like in order to rewrite the language in itself, why don't you use Python? Python? I don't like Python. Python is bad. I don't want to use a dynamically typed language. I don't like having bugs. You see, I'm a bad programmer, so I need a compiler to check that I'm not making bugs. Which is why I was using Rust, which is why I'm considering Haskell or like PureScript if it's not too crippled of a language. I just don't know what it is. I just heard something about it. Is there? Maybe we can just try it. I can just try it for a day and like go through the book or something, and see if I miss some feature that I really want. Documentation by example. Is there even like a book or anything for this language? Try PureScript. We're just going to run this code, right? We just render some HTML with code here. Okay, yeah, that makes sense. I don't really care. I don't really care about like the front end stuff though. The PureScript book. I just want to see the chapters. Functions, records, pattern matching, recursion maps, type classes, applicative validation, the effect monad. Asynchronous effects. Okay. We can write the entire thing in an async language immediately. All in JavaScript. Monadic adventures. This is making a game in this language, right? I don't see something like generating code, right? Like, is there a way to like derive a type class in PureScript? You don't just derive type classes like you do in Haskell with deriving. PureScript is more manual about this jazz. So like you can use the derive keyword if the type class supports it. If it doesn't support, then you have to write it yourself by hand, like some kind of a coding caveman. So I cannot implement a custom derive. Does not support custom derive. You got two options. Lady helper functions. Yes, it sucks. No, it won't feel good. All right. Let's just see. Let's do a poll. Rust, Zig, Haskell, or Camel. What else? TypeScript. There you go, there's a poll. Not that it's going to matter. Zig and Camel. TypeScript. Zig. All right, I'll think about it. Maybe it could be Zig. But I don't know. I feel like if I oh shit, I tried to do that here. Right. I feel like if I try Zig, I will rage quit pretty quickly. Free memory in 2025. I mean, maybe we don't free it. Maybe we just like we only allocate and leak all the memory. You know, like that's how you do memory management. You just you only allocate, you never free, right? And maybe that's fine for the compiler. We don't worry about memory management. We just allocate for like and never free. Yeah, that's how you do the programming. Just to not worry about it. Like everything is basically static. So you don't worry about the lifetimes. You can do the same in Rust. Just create a new box and leak it, and you have a static reference. Patlang. Fetish themed programming language. Statically typed, by the way. Yeah. Alright. See you guys next time. Thank you for watching. Bye. The compile times have not been fixed.